Hey guys, welcome to Sleepumentary. If this evening is helping you drift into calm, leave a like and subscribe, but only if it rises naturally from you. I'd love to know in what part of the world are you now and what time glimmers on your clock. Plastics, pesticides, industrial chemicals, rare metal alloys. Some of these vanish quickly, broken down by sunlight or air. Others resist clinging to soil, sediment and oceans in ways that outlast those who made them. They linger like whispers, scattered fingerprints on a planet that never stops rearranging itself. But here's a question that pulls at something deeper, something at once thrilling and uncomfortable. What if these are not the first such fingerprints? What if long before pyramids rose from desert sands or satellites circled in silent arcs above us, another intelligence walked this earth, building, creating and eventually disappearing so completely that the planet itself has forgotten? Not a mythical Atlantis, not alien visitors leaving cryptic monuments, but something homegrown. A civilization born of Earth's own biology. A people or creatures who thought, who built, who lived with ambitions and failures. Something that flourished then faded so many millions of years ago that even memory surrendered, and the layers of rock pressed down until their stories were unreadable. It sounds like the premise of science fiction, and in a way it is. Yet it's also a serious question tucked into quiet conversations among geologists and cosmologists. If another civilization had existed, would we even know? Or has the slow machinery of Earth erosion tectonics time itself swallowed them entirely? The unsettling possibility is not that they are out there waiting to be discovered like buried cities beneath Antarctic ice, or smartphones trapped in seams of coal. It's subtler, more disorienting. Perhaps the ruins are already gone, melted into stone, transformed into dust, erased so thoroughly that only faint chemical echoes remain, the kind of signals most of us would never think to notice. Our skyscrapers and roads give the illusion of permanence, but permanence is a story we tell ourselves. The truth is, Earth is relentless at cleaning its canvas. Pause for a moment with that thought. Imagine you are holding a globe in your hand, smooth and weighty, 4.5 billion years old. Every ridge and ocean you see on its surface is temporary, just a passing arrangement. Continents split and collide, oceans open and close, mountains rise and wear away. Now imagine trying to find a needle in that shifting fabric. Not a monument of stone, but a trace of thought, a ghost of culture. That is the scale of the challenge before us. And yet here we are at this precise second, you're listening in your room somewhere, speaking across wires and waves, both of us suspended in this fragile present. We like to believe history is long, but in geological terms it is almost nothing. The earliest temples, the first scripts carved into clay, the builders of Stonehenge, all of them lived only 10 or 12,000 years ago. To us that feels unimaginably ancient. But to Earth it's barely yesterday, a blink of an eye. If another civilization had come and gone 10 million years ago, would we have any chance at all of knowing? That question is both haunting and strangely comforting. Haunting because it challenges the pride we place in our own uniqueness. Comforting because it suggests that intelligence, our endless curiosity, our hunger to shape the world may not be an accident, but a possibility woven into the fabric of life itself. Perhaps we are not the first to look at the stars and wonder. Perhaps we are not the only dreamers this planet has ever carried. Before we begin the long descent into those billions of years, let me ask you something simple. Where are you right now? What time is it where you sit listening? It might be midnight in your city, the quiet hours when the hum of the world softens. Or perhaps it's late afternoon sunlight fading across your desk. Whatever the moment, this small intersection of our lives is fleeting, almost invisible compared to the eons we are about to explore. Yet here we are bound for a little while by a single question. Are we truly the first? It's a funny contrast. We speak of civilizations lost to time of lives, erased so thoroughly they no longer have names, while at the same instant we share this fragile present, seconds, minutes, unnoticed by the planet beneath us. For Earth, this moment does not matter. For us, it matters entirely. You and I, separated by distance but connected in curiosity, are about to press our imaginations against the most patient storyteller of all geology. So settle in. Let your breathing slow to match the quiet rhythm of the planet itself. Think of continents shifting with the grace of glaciers, oceans deepening like bowls carved over millennia, mountains rising and falling as if exhaling. That is the pace of the story we're entering. Not the hurried tempo of kings and wars, but the endless heartbeat of stone and sediment. Because before we ask whether another civilization might once have lived here, we need to reckon with the scale of time itself. To us, a century can feel eternal. 1,000 years can seem like forever, but in the language of the Earth, even 10,000 years barely earns a footnote. The first cities, the first alphabets, the first monuments, they are all so close to now that they could almost be considered part of the same breath. Against the backdrop of 4.5 billion years, we humans are newcomers, toddlers learning to walk across a very ancient floor. This is why the question unsettles us. If civilizations had bloomed before ours, they would be buried not beneath sand alone, but beneath epoch's entire reshaped landscapes. And unlike the faded ink of old manuscripts or the worn stones of forgotten temples, their traces would not sit waiting in plain sight. They would lie hidden in places we rarely think to look locked, in cores of ice, sealed within sedimentary rock disguised as chemical anomalies. And yet, as you lie back or lean forward listening now, you're part of this same fragile chain of record. A witness, however small, to the fact that thought happened here, that someone asked the question, that tonight in this shared but passing moment 2 minds brushed against the abyss of deep time and wondered whether others once did the same. When we speak of ancient history, our minds usually drift to the pharaohs of Egypt, the shadowed stones of Stonehenge, or clay tablets etched with the earliest scripts. These memories reach back perhaps 10 or 12,000 years, a staggering depth for us already enough to fill whole libraries with debate and mystery. Yet even this expanse is barely a flicker compared to the immensity of the Earth's story. The Earth is not merely old, it is staggeringly, almost incomprehensibly old. About 4.5 billion years, give or take a few hundred million. That number is easy enough to say, but nearly impossible to feel. Imagine a single day's stretch to represent the entire history of Earth. Humanity's entire existence would appear in only the last few seconds before midnight, our recorded history just the faintest tick of the final second. Everything we know, our temples was art songs compressed into a breath. For most of that vast timeline, there were no humans, no mammals, not even plants on land. Life clung to oceans in microscopic obscurity, experimenting quietly with forms that came and went before the world ever noticed. Trilobites scuttled across seabeds hundreds of millions of years before the first dinosaur even hatched. Forests once covered continents that no longer exist. Entire mountain ranges rose skyward, wore away, and crumbled into the sea while the planet continued to circle the sun silent and patient. This is the scale at which we must think if we're to take our questions seriously. Because deep time doesn't simply pass, it acts, it erases. Wood rots, metal rusts, bones dissolve. Mountains crumble grain by grain. Oceans spread and vanish. Even continents are temporary, their edges swallowed into the furnace of the mantle by the slow but relentless drift of tectonic plates. In the face of this machinery, permanence is an illusion. Consider this. The oldest seafloor in the world is barely 200 million years old. Every inch of ocean bottom older than that has already been dragged down, melted and recycled. That means if an advanced civilization had flourished along a coastline 300 million years ago, every trace of it could have vanished into magma long before the first human ancestor walked upright. We like to think of stone as eternal, yet even the hardest granite bends, flows and disappears when given enough time. And this is why the possibility of a forgotten civilization feels both tantalizing and impossible. It's not that evidence would be difficult to find, it's that the very conditions of Earth make survival extraordinary. Anything that persists across millions of years is already a miracle. The rare fossils we have, the few preserved imprints of shells or leaves, are less like ordinary records and more like lightning strikes, rare alignments of luck and circumstance. So when we ask whether others came before us, we must understand the enormity of what stands against their memory. Time is not just deep, it is abyssal, bottomless. And if we hope to glimpse even a shadow of what might once have been, we will need to learn to read not history but geology, the slow and secret language of stone. The Earth, for all its beauty, is not a patient archivist. It does not keep every memory with care. Instead, it is a restless editor, forever rewriting its own story, erasing whole chapters as easily as waves smooth footprints in wet sand. If there is one truth that geology insists upon, it is this: survival is the exception, not the rule. Look at mountains. To us they feel eternal majestic walls against the sky, yet even the highest peaks are temporary. The Himalayas today thrusting into the clouds were once seabed, their limestone packed with the fossils of ancient marine creatures. They rose only because India crashed into Asia like a slow-motion collision. In time they too will wear down their grandeur, reduced grain by grain to sand carried by rivers. What seems permanent is only the latest draft of a shifting planet. Consider the continents themselves. They are not fixed land masses but wandering rafts. Gondwana once sprawled across the southern hemisphere, binding Africa, South America, Antarctica and Australia in a single vast continent. Pangaea before that bound nearly all land into one. Each supercontinent assembled, broke apart, drifted, collided, and will do so again. If you tried to search for an ancient civilization, you might not even find the land where it once stood. It may lie buried miles beneath another continent or scattered across different hemispheres. The oceans too are tireless erasers. Beneath their surface, tectonic plates move apart, creating new seafloor. Elsewhere, those plates slide under continents, dragging the ocean crust into the mantle where heat and pressure recycle it into new rock. The seafloor is young because it cannot last. Whatever might once have been built there is gone, swallowed, melted, and reformed into something unrecognizable. Even the sky plays its part. Wind and rain gnaw at stone, carrying away what centuries of hands may have shaped. Rivers slice through valleys, floodplains, bury ruins. Beneath layers of sediment, deserts march slowly over towns. In places where preservation does occur, like volcanic ash entombing Pompeii, it is often catastrophe, not stability, that safeguards the past. Think of how little of human history we have uncovered despite it being so recent. We know of entire cultures from only a handful of artifacts, pottery shards, or burial sites. How much more impossible would it be to recover the traces of a people who lived not thousands but millions of years ago? If such a civilization existed, their monuments may have been ground into dust, their tools reduced to ore, their stories pressed into stone so deep we can no longer tell them apart from nature's own designs. The earth does not hoard memories, it recycles them. And in this endless cycle of building and unbuilding, the past becomes a ghost, sometimes visible in fragments, sometimes gone completely. Which means that if another civilization rose before ours, the question isn't just whether they left a trace. The question is whether the earth allowed that trace to survive at all. So let's allow ourselves the thought, fragile though it may be. Imagine the clock rewound 100 million years. Dinosaurs stalk the land, the air thick with the wing beats of pterosaurs. The world is warmer, seas are higher, and the continents wear shapes both familiar and strange. In this setting, could another intelligence have quietly taken root? Not a myth dressed in marble or bronze, but a species that rose, lived, and vanished, its legacy erased long before we appeared. Picture them. Perhaps they stood upright, or perhaps they never needed to. They might have been aquatic, dwelling in shallow seas and kelp forests, shaping their world beneath the waves. Or they may have thrived on land-weaving tools from materials now long gone, fibres, bone resin, things the earth would happily consume without leaving a trace. Maybe they never worked in stone at all. Maybe they built no monuments we would recognise. Their technology might have been subtle, relying not on bronze or iron, but on methods we have no name for, processes invisible to us now. And still they might have known what it meant to shape a society, to pass knowledge from generation to generation. They may have organised themselves, cultivated food, stored memory, even pondered their place in the cosmos. Civilizations need not be measured in skyscrapers. Sometimes they are measured in shared rituals, in the quiet orchestration of life at scale. Now imagine their end. It could have been sudden an asteroid strike, a supervolcano, a shift in climate they could not adapt to. Or it could have been slow, a long decline, their cities abandoned one by one, their knowledge thinning until silence reclaimed them. Time does not care for the reason. Once they were gone, the planet began its work, erasing their record, folding their traces into stone, until nothing remained but the vaguest whispers in chemical anomalies and broken sediments. We stand here millions of years later asking whether they were ever real, and the unsettling truth is that we might never know. For all our science, for all our tools, the Earth is far better at forgetting than remembering. If another civilization lived and died long before us, their absence is not suspicious. It is natural. In fact, what would be surprising is if anything survived at all. This is the paradox. Our curiosity insists on asking, but the record of the Earth answers mostly with silence. Yet still the question lingers, what if we are not the first? When we imagine the survival of civilizations, we often picture our own as somehow more enduring, more permanent. Surely our skyscrapers of glass and steel, our highways carved across continents, our satellites glittering in orbit will resist the passage of time. But this confidence is an illusion. The truth is even our greatest works are fragile against the long patience of the Earth. Leave a city unattended for just a few decades and nature begins its quiet conquest. Roots pry open sidewalks, ivy climbs walls, rain seeps into steel rust spreading like a slow disease. Consider the Chernobyl exclusion zone, abandoned since 1986. Already deer wander freely through schoolyards, wolves hunt among apartment towers, trees sprout from rooftops. The works of human hands surrender swiftly once maintenance ends. Look further back. The jungles of Central America reclaimed entire Maya cities, covering temples and plazas in a green-shorn shroud so complete that for centuries no one knew they were there. In Cambodia, Angkor Wat lay forgotten, swallowed by roots that seemed to grow deliberately through carved stone. In the deserts of Petra facades that once blazed with life now crumble in silence, sand slowly wearing their faces away. These places feel eternal to us, yet they are young compared to the rhythms of geology, and already they fade. Even modern infrastructure built with concrete and steel is not immune. Bridges collapse when bolts corrode, asphalt roads split as weeds push through. Skyscrapers, magnificent while occupied, can become dangerous shells within decades when power fails and maintenance ends. In wetter climates, whole buildings could collapse in less than a century. Our monuments so tall and proud today would become rubble in only a few thousand years, an instant in geological time. If this is true for us, then it must also have been true for any civilization before us. The Earth does not discriminate. Whether Mayan stone, Roman concrete, or modern steel all dissolve under its patient hand. What feels indestructible in a human lifetime is laughably temporary measured against millions of years. That realization unsettles. We are not the eternal species we like to imagine. We are brief. Our works are brief. The soil, the rain, the mountains, they will outlast us just as they outlasted countless worlds before. Which means that if a forgotten civilization once walked this earth, the fact that we cannot see them does not mean they were never here. It may only mean that the earth has done what it always does: erase, recycle, begin again. If you want proof of just how ruthless the earth can be in deciding what remains, you need only look at the fossil record. For every skeleton displayed in a museum, there are countless creatures that left no trace at all. Fossilization is not the natural end of life, it is the rare exception. Most organisms never come close to becoming fossils. When a body falls in the open, scavengers tear it apart. Bacteria break it down. Rain and sun finish the job, returning it to soil and air. To preserve even a fragment, an improbable sequence of events must align. The body has to be buried quickly, sealed away from scavengers and decay. Minerals must seep into its tissues, replacing them slowly with stone. The site itself must avoid being eroded, crushed, or melted by tectonic activity, and then finally it must survive long enough to be uncovered by chance in a quarry or cliff face. This is why the fossil record feels like a patchwork quilt with more holes than fabric. Entire species vanish without a whisper. Entire forests once sprawled across continents and left only a handful of impressions in stone. Consider the Burgess Shale in Canada, an astonishing snapshot of marine life 100 million years ago, preserving creatures so delicate they should never have survived. That deposit is famous precisely because it is so rare. Elsewhere, millions of years pass without so much as a bone or shell to testify. Now imagine trying to preserve not just bones, but artifacts of culture tools, structures, writing. Stone flakes might last if we are lucky. Pottery fired hard might endure in fragments. But wood, leather, cloth, metal, these materials vanish quickly, eaten by the Earth's endless appetite. Even when something does survive, it can be maddeningly ambiguous. A chipped stone might be a tool or simply a rock broken by frost. Without context, without pattern, it's nearly impossible to decide. This is why the absence of evidence cannot easily be taken as evidence of absence. The fossil record is sodlant more often than it speaks, and when it does, its voice is selective whispering of only the luckiest survivors. If this is true for bones and shells, how much truer must it be for the fragile traces of a civilization erased, not thousands but millions of years ago? The odds are stacked against remembrance. To find a trace at all would be like catching the faintest glimmer of a candle across a canyon in the dark. And yet, even knowing how rare survival is, we keep looking, because the alternative that we might not be the first is too provocative to ignore. So perhaps it is no surprise that in 2018, two scientists, Gavin Schmidt, a climate scientist at NASA, and Adam Frank, an astrophysicist, decided to take this question seriously. They were not chasing myths or hoping to prove lost continents. Instead, they asked something more disciplined, almost clinical. If an industrial civilization had existed millions of years ago, what would we expect to find in the geological record? They gave their thought experiment a name, the Silurian hypothesis. The term was borrowed playfully from a British science fiction series in which a race of intelligent reptiles, the Silurians, once ruled the Earth before humans. The scientists, however, were not making such claims. Their focus was methodological. How would we even know what tools of geology could possibly detect such a ghost of industry? The heart of their idea was this: civilizations leave waste. They leave fingerprints in chemistry and climate, not just in monuments and machines. Our own species is writing itself into the Earth's archives right now in ways far subtler than skyscrapers or satellites. Plastics buried in the soil, pesticides soaking into sediments, radioactive isotopes from nuclear testing woven invisibly into layers of rock, shifts in carbon and nitrogen cycles as fossil fuels pour into the atmosphere. These are not relics in the ordinary sense, but signals. Schmidt and Frank asked if humans were gone tomorrow, how would future geologists detect us millions of years later? And then, turning the mirror backwards, they asked if another civilization had once existed, could its fingerprints already be buried in the layers we have drilled and studied but dismissed as natural anomalies? That was the uncomfortable possibility. For if Earth has already erased so much of its past, perhaps what remains are only faint chemical echoes easy to mistake for volcanic eruptions, methane releases, or asteroid impacts. We might already have stumbled over the fingerprints of another age and filed them quietly under natural event. The Silurian hypothesis was never meant to prove that such a civilization existed. It was instead a reminder of how incomplete our record is, and how dangerous certainty can be when the evidence itself has been largely erased. In this way, it became less about lost civilizations, and more about humility about how little we truly know of the deep past. But the hypothesis also served another purpose. It forced us to think of ourselves not as eternal, but as temporary. It asked us to consider what traces we will leave behind when time has finished with us. And it whispered an unsettling question. If we are so fragile, then how many times before has this planet reset, leaving only silence where once there might have been voices? If our cities and machines crumble too quickly to last, then what survives? The answer Schmidt and Frank suggested is not architecture, but chemistry. Civilizations alter the balance of the planet itself, and those changes can be written into the soil, the oceans, and the air. We are doing this right now. Plastics swirl in gyres the size of continents, breaking down into microfragments that fall with the rain and drift in polar snow. Fertilizers and pesticides transform entire river systems, etching a chemical scar into the soil that will outlast the farmers who spread them. Concrete poured on such a scale that it now outweighs all living plants is already fusing into new geological formations, what some geologists call urban strata. Most striking of all is the atmosphere. In just 2 centuries of burning coal, oil and gas, humans have changed the carbon cycle that remained relatively stable for millions of years. Carbon isotope ratios in the air and oceans now carry a distinct fingerprint one future geologist could read as clearly as a headline. It is not simply more carbon. It is carbon of a particular kind, lighter drawn from ancient fossil reservoirs, a chemical quirk that cannot be explained by volcanic eruptions alone. And there is more. Since 1945, nuclear testing has scattered radioactive isotopes across the globe, atoms that do not occur naturally in such abundance. Strontium-90 in the bones of animals, cesium-137 in soils. These isotopes have half-lives long enough to whisper of our presence for tens of thousands of years, perhaps longer, depending on where they are buried. Future geologists might find them compressed in sediments, puzzled by the sudden global spike of radioactive dust. This is why many scientists now speak of the Anthropocene, a proposed new epoch in Earth's history, defined not by ice ages or asteroid strikes, but by us, human beings as a geological force leaving a layer in stone that says unmistakably something was here. Some argue that the beginning of this epoch can be marked with the Industrial Revolution. Others point to the great acceleration after World War II when population, technology and resource use exploded. Either way, we are already engraving ourselves into the rock. It is humbling to realize that these fingerprints, plastics, isotopes, altered cycles of carbon and nitrogen are far more durable than our monuments. The Eiffel Tower will rust, the Great Wall will crumble, our satellites will fall. But a thin chemical line in sediments, a shift in isotope ratios, a scattering of strange polymers, these may endure long after our stories are dust. And so the question sharpens. If we can change the Earth so deeply in mere centuries, could not another civilization long forgotten have done the same? And if so, might its legacy already be buried under our feet, disguised as nothing more than an unexplained anomaly in the chemistry of ancient stone? To imagine where such anomalies might hide, we first need to face an uncomfortable truth. The Earth's record is full of missing pages. We like to picture geology as a great book of time, every layer a chapter stacked neatly on top of the last. In reality, it is more like a tattered manuscript, burned, erased, rewritten, and riddled with holes. Geologists call these holes unconformities. They are gaps where millions of years of history simply vanished. Sometimes the land was never depositing sediment in the first place. Other times layers that did form were later scraped away by wind, water, or ice. Stand at the rim of the Grand Canyon and you can see it clearly. Bands of red and gold and grey stacked like pages in a book, but with entire chapters missing eras erased so cleanly that the story skips ahead without explanation. Think too of impact craters. Asteroids have struck Earth countless times, some with catastrophic force. Yet only a handful of craters remain visible today. Many have been buried, eroded, or deformed beyond recognition. The famous Chicxulub crater in Mexico, the one linked to the extinction of the dinosaurs, was hidden for decades beneath limestone and jungle. It was not discovered until scientists noticed subtle anomalies in gravity and rock chemistry. If something as immense as an asteroid strike can nearly vanish, what hope would there be for a city or even a civilization? The gaps grow wider the further back we look. Entire oceans have opened and closed without leaving a clear trace. Mountain ranges have risen and worn away until not a single peak remained. Imagine trying to reconstruct the history of a library when 3/4 of its shelves have been burned and the rest reshuffled. That is what deep time gives us, a story constantly edited with only fragments surviving. And yet these very gaps hold a strange allure. Because in the silence of what is missing, we are left with questions. If there were once civilizations before us, their traces may not be gone in the sense of destroyed. They may simply be buried in those lost chapters, wiped away or transformed, until they no longer resemble anything we would think to call evidence. It forces us to admit how fragile our knowledge really is. The fossil record is rare, the sedimentary record is patchy, even the continents themselves are restless. To demand certainty that no one came before us is to underestimate just how easily Earth misplaces its memories. Which means the mystery does not lie only in what we see, it also lies in what is gone. Before we continue our search for ghosts in the rock, we should pause and ask a deceptively simple question. What do we even mean by civilization? If we cannot define it, how will we know what to look for? In everyday conversation, the word conjures skylines, written records, marble temples, governments, and laws. But this is a narrow and very modern lens. History itself shows us that civilizations can take countless forms. The Inca Empire left behind no written language in the sense of alphabets, but they built roads spanning thousands of miles and developed intricate systems of accounting with knotted cords called quipus. Ancient Mesopotamia gave us cities and writing, but much of their society still depended on fragile clay tablets that could be destroyed in a single fire. Archaeologists prefer a broader set of criteria. A civilization is not just a city, but a pattern of surplus food that allows people to specialize systems of governance or shared ritual, symbolic communication, long-distance trade, and cooperation on a scale that stretches across generations. Not every civilization ticks every box, and some blur the lines between village and city, tribe and state. But the essence lies in complexity, the deliberate organization of life beyond mere survival. Take Çatalhöyük in modern-day Turkey, nearly 9,000 years old. It had no streets, no towering monuments. Homes were packed together so tightly that people entered through ladders in their roofs, and yet it is recognized as one of the earliest urban settlements because what mattered was not its skyline but its coordination, shared walls, communal rituals, collective burial customs. This too was civilization, though it looked nothing like the cities we know today. So when we wonder about the possibility of a forgotten civilization millions of years ago, we must let go of our assumptions. We are not necessarily looking for pyramids, palaces, or industrial ruins. Civilization could take forms we barely recognize, distributed, ecological, ephemeral. It could be marked less by monuments of stone than by patterns of behavior, species farming, storing knowledge, altering their landscapes intentionally. Think of termites building mounds with ventilation systems that regulate heat and moisture. To us, they are nests of dirt. To another eye, they might look like the beginnings of architecture. Scale it up, bury it for a few million years, and would we recognize the difference? Perhaps the real signal of civilization is not what was built, but whether something was built at all with foresight, intention, and continuity. In this way, civilization is best understood not as a finish line, some great leap to cities and empires, but as a spectrum. At one end lies the bare struggle for survival. At the other, the deliberate reshaping of a world. Everything in between may count, and in that vast middle ground there is room for more than one story. When we think of intelligence, we usually picture ourselves language tools, cities glowing with light. But intelligence wears many faces, and not all of them look like ours. If another civilization rose and fell before us, it may not have resembled humanity in the slightest. Consider the termite mound. To us it is only a lump of earth easily overlooked, yet inside it breathes with astonishing design. Intricate tunnels regulate temperature and moisture. Fungus farms thrive in carefully maintained chambers. The colony behaves as one organism, its individuals carrying fragments of a larger intelligence. To dismiss it as instinct is to miss the scale, millions of years of refinement producing architecture and agriculture long before humans appeared. Or look to coral reefs. They are not civilizations in the human sense, but they are collective builders layering skeletons of calcium carbonate into vast structures visible from space. These living fortresses alter entire coastlines, shape ecosystems, and endure across centuries. To future eyes, their ruins might resemble the remnants of an organized project, even if no single mind was in charge. Even among mammals, there are hints of sophistication that might vanish without a trace. Dolphins teach hunting techniques across generations, a form of cultural inheritance. Elephants mourn their dead, revisiting the bones of lost family. Crows craft tools and pass the skill to their young. These behaviors leave no monuments, no inscriptions, yet they show that intelligence does not have to look like stone columns or bronze statues. Now imagine an intelligent species that never built with rock, that never smelted metal, that never needed to. Perhaps it lived in forests, weaving structures from wood and fiber materials that rot within decades. Perhaps it was aquatic, relying on sonar or chemical signals to share memory, leaving almost nothing tangible behind. Even if such a civilization reached great complexity, how much of it would survive millions of years later? Almost nothing. And then comes the deeper question. Would we even recognize it if we found it? A fossilized termite mound could be dismissed as natural geology. A coral structure could be written off as biology, not design. Our bias is to look for ruins, tools, things shaped unmistakably by hands like ours. But intelligence may not always leave those kinds of markers. It might speak a different language, one of pattern, of chemistry, of traces we have not yet learned to interpret. This is where humility enters. The danger is not just that the evidence is gone, but that it may be right in front of us, misclassified, ignored, or dismissed because it does not match our narrow expectations. The Earth may already hold the ghosts of civilizations we do not recognize, not because they are invisible, but because we have not learned how to see them. When imagining civilizations lost to time, we often picture them as enduring for tens of thousands of years, carving monuments meant to outlast the ages. But in truth, a civilization doesn't need long to make a mark. Human history proves this all too clearly. Consider how swiftly our own species has transformed the planet. In just a few hundred years of industrial activity, barely a heartbeat in geological terms, we have altered the carbon cycle, shifted nitrogen levels in the soil, filled the oceans with plastic, and scattered radioactive isotopes across the globe. If humanity were to vanish tomorrow, those changes would still be legible in the geological record millions of years from now, not in the form of ruins or tools, but as chemical signals, thin lines in sediment cores, isotope ratios that speak of fire, and fuel traces of molecules that nature does not make. So perhaps longevity is not the key. A civilization does not need to last forever to leave a mark, it only needs to burn brightly enough. Think of the Roman Empire, a force that reshaped Europe and the Mediterranean in barely 5 centuries. Roads, aqueducts, law codes and languages spread like wildfire, leaving echoes that persist even now. Or the Maya, whose great cities rose and fell in less than a millennium, swallowed by jungle but still remembered in stone. Even Easter Island, a small and isolated society, altered its entire ecosystem in a few centuries, leaving statues that still watch the sea. Now scale these examples up or down. Imagine a civilization that lasted only a few thousand years but was industrial in scope, burning fuel, altering landscapes, shifting atmospheres. Even if every trace of its buildings and machines were gone, the chemistry of its age might endure. A sudden spike in carbon isotopes, an unexplained drop in biodiversity, a thin layer of ash or strange compounds pressed into rock. These could be the only whispers left to mark their existence. The unsettling truth is this: civilizations may not need to last long to be remembered by the Earth. They only need to change it enough. And if we are already altering the planet in ways that will echo long after our monuments crumble, then the same may have happened before. The question is not only whether another civilization existed, but whether its signal is hidden in plain sight, written into stone we have already studied, misfiled as a natural catastrophe, or dismissed as coincidence. We often think of time as passive, like sand piling up in an hourglass. But on Earth, time is anything but gentle. It is active, restless, destructive. The planet is not a library that carefully preserves what is placed on its shelves. It is a forge forever breaking down and reshaping its own materials. Start with weathering the slow bite of wind water and temperature. Rain seeps into cracks, freezing and thawing until even granite splits apart. Heat expands cold contracts, and over centuries rock shatters into sand. Metals oxidize, turning strong iron into fragile rust. Roots creep into stone and concrete alike, forcing them open and grain by grain. Give nature a few decades without resistance and a palace becomes a ruin. Give it a few thousand years and that ruin becomes indistinguishable from the hill on which it stood. Then comes sedimentation. Dust silt, volcanic ash all fall steadily blanketing what lies beneath. At first, this burial may preserve protecting fragile remains from exposure. But as layers accumulate, pressure builds. Over millions of years, entire cities would be flattened, compressed, transformed into stone. A column of marble might survive as a distorted vein in limestone. A statue could become nothing more than a faint outline, the details long gone. Tectonic forces make the erasure even more thorough. The Earth's crust is broken into plates that drift upon molten rock, colliding and pulling apart. Where they meet, mountains rise and earthquakes tear the surface open. Where they diverge, new seafloor is born. And where one plate slides beneath another, entire landscapes are dragged down into the mantle, melted and recycled. The average age of the ocean floor is just 200 million years, barely 5% of Earth's history. Everything older has been consumed. If a civilization once lived on islands or coasts, their traces are likely gone, reduced to magma that will someday emerge again as fresh rock. Even cataclysm preserves only briefly. Pompeii survived not because it resisted time, but because disaster struck, swiftly burying the city in ash and sealing its forms. Yet even Pompeii is not eternal. The ash that preserved frescoes and bodies also weakens, crumbles and erodes. Already parts of the city are fading again despite our best efforts to protect them. If one of the most famous time capsules in history is slipping through our fingers after only 2 millennia, what chance does a forgotten civilization have after tens of millions of years? The lesson is stark. Earth does not simply allow civilizations to disappear, it actively destroys them. Wind, water, firestone, and the grinding gears of plate tectonics are relentless editors, erasing stories almost as soon as they are written. Which means that when we look into the deep past, the silence we hear may not be the silence of absence. It may be the silence left behind by a planet that does not keep what it is given. If the Earth is so skilled at erasing, how do we know anything at all about the people who came before us? The answer is by scraps. Archaeology is the art of reconstructing entire worlds from fragments so small they barely whisper. A flint knife discovered in the soil might be the only surviving trace of a hunting camp that once fed generations. A single shard of pottery baked in a fire thousands of years ago can reveal not just what people ate, but how they cooked, traded, and lived. Sometimes archaeologists infer entire settlements from little more than dark stains in the soil, ghostly outlines of post holes where wooden houses once stood, the wood itself long since rotted away. And it is not only survival that is rare, recognition is fragile too. A shaped stone may be dismissed as natural unless found alongside dozens of others. Patterns matter: repetition, context, association. Without them, we risk overlooking what once mattered most. Entire cultures could have existed, their traces hidden in plain sight, mistaken for coincidence or geology. History is full of such blind spots. The Indus Valley Civilization, one of the world's great urban cultures, left behind vast cities of brick but no readable writing. For centuries after their rediscovery, archaeologists debated whether they were truly a civilization at all. The Olmecs of Mesoamerica were once known only through scattered artifacts, massive stone heads too strange to explain until broader excavation revealed their sophistication. And the Denisovans, a sister species to Neanderthals, were discovered only from a few fragments of bone and teeth in a single Siberian cave. Without genetics, we might never have known they existed. Now magnify those blind spots by millions of years. Imagine not fragments of pottery or flint, but chemical residues, distorted, buried, and stripped of context. Even if we stumbled upon them, would we recognize their meaning, or would we file them away as curiosities puzzling but unimportant, just as earlier archaeologists did with artifacts they could not yet interpret? Archaeology teaches us humility. We do not hold a complete record of humanity's past, we hold fragments stitched together with imagination. Our reconstructions are provisional, always vulnerable to new discoveries. If this is true for events just a few thousand years old, how much more uncertain must we be when asking about civilizations tens of millions of years beyond our reach? The silence in the record does not mean nothing happened. It may only mean we have not yet learned how to hear it. Even when something does survive, we face another trap. Nature itself is a skilled mimic. The Earth can shape forms so precise, so deliberate-looking, that they trick the human eye into believing design where none exists. Think of a geode. Split open, its crystals fan outward in symmetry so exact that they might be mistaken for careful craftsmanship. Or consider the strange, near-perfect stone spheres found in places as far apart as Costa Rica and South Africa. Some are human-made, others entirely natural, formed by slow accretion of minerals around a central nucleus. Without context, how do we tell the difference? This problem extends across geology. Concretion's rounded nodules of mineral matter can resemble carved beads. Erosion carves, faces into cliffs, arches into stone, even roads across desert plateaus. Iron deposits stain rocks in sharp geometric patterns. A random fracture can leave a stone flake that looks at first glance like a tool chipped by human hands. The line between artifact and accident is finer than we like to admit. Archaeologists know this all too well. A single object is rarely enough. It must be compared with others saw, studied in context, examined for microscopic wear that suggests use. But in the deep past, context is almost always lost. Layers have shifted, compressed or eroded. What remains might be nothing more than a solitary oddity, stripped of the clues that would make its meaning clear. And so we hesitate. Even when confronted with something unusual, science leans toward caution. It is safer to say natural anomaly than to invoke a vanished civilization. A carved figure might be dismissed as weathered stone. A patterned deposit might be attributed to volcanic chemistry. Extraordinary claims require extraordinary evidence, and evidence is precisely what deep time refuses to provide in abundance. This leaves us in a strange position. If a civilization did exist millions of years ago, its remains might not only be rare, they might be indistinguishable from the countless imitations nature produces effortlessly. The Earth does not just erase, it confuses, cloaking its past in riddles that look familiar but speak no clear language. Perhaps we have already held such a clue in our hands and let it slip away catalogued as a curiosity of geology rather than a relic of intelligence. If so, the tragedy is not that the evidence was lost, but that we never recognized it when it was right before us. If direct artifacts are so easily destroyed or disguised, perhaps the better path is not to search for statues or tools at all, but for signals, the kinds of disturbances in the Earth's systems that only intelligence could create. This is the logic behind the Silurian hypothesis. Civilizations leave fingerprints not in monuments but in chemistry. One clue might be isotope ratios. When humans burn fossil fuels, the carbon released into the atmosphere carries a distinctive isotopic signature, a lower ratio of carbon-13 to carbon-12. Future geologists digging through our sediments millions of years from now would see the sudden drop and know something unusual happened. If such a spike existed in the distant past, might it point not to volcanoes or methane releases, but to industrial combustion? Another potential signal lies in synthetic compounds. Plastics, pesticides, and industrial chemicals do not occur naturally. Even if most break down, some residues can linger in sediments transformed but still recognizable. A layer filled with strange polymers or halogenated molecules appearing globally at the same time could raise questions no volcanic eruption could answer. There are also unusual metal concentrations. Mining and refining leave waste signatures, spikes of lead, cadmium, or rare earth elements. These metals don't simply vanish, they travel through soils and rivers, settling in patterns that could survive far longer than the societies that produced them. A sudden global uptick in such concentrations might speak of industry rather than geology. Even biology itself carries clues. Human activity has already accelerated extinction rates, fragmenting ecosystems at a pace rivaling past mass extinctions. If another civilization once consumed landscapes, their impact might show up as a sudden collapse in biodiversity, a sharp drop in the variety of fossils across a thin layer of sediment. To future eyes, it might look like a catastrophe without a clear cause. The difficulty, of course, is that nature can produce similar patterns. Volcanic eruptions release carbon and heavy metals. Asteroid impacts scatter rare elements and trigger die-offs. Methane bursts can mimic industrial carbon shifts. Separating the natural from the artificial requires not just a single anomaly, but a constellation of them patterns that suggest intention, not accident. And this is where our imagination collides with humility. For if such signals already exist buried in the cores we drill and the rocks we study, we may not yet know how to read them. Perhaps we have already seen the fingerprints of another age and assume they belong to volcanoes or oceans. Perhaps the traces are there, thin and ambiguous, waiting for someone to ask the right question. The search for a forgotten civilization then may not be about uncovering ruins at all. It may be about learning to hear whispers in the chemistry of the Earth, to recognize that sometimes the planet's story includes actors we did not expect. When most people hear the word fossil, they imagine a dinosaur skeleton bones gleaming under museum lights arranged neatly, as though the creature simply lay down and turned to stone. But fossils almost never look like that. They are fragments, compressed shadows of what once was. Preservation is rare, capricious, and incomplete. And when it comes to civilizations, the odds grow even slimmer. What then might count as the fossils of civilization? Not bones or statues, but the things most likely to resist the slow grind of deep time. A few stand out. Ceramics and glass. These are chemically stable, stubborn against decay. Shards of pottery from ancient Mesopotamia are still sharp to the touch after 6,000 years. In the right conditions, buried undisturbed, they could last millions. A scattered layer of glass fragments in some ancient strata might to future eyes hint at a vanished industry. Yet without context, they could be dismissed as volcanic glass or natural obsidian. Concrete. Surprisingly resilient, it sometimes grows stronger with age. Roman concrete infused with volcanic ash has endured in seawalls for 2 millennia, defying the waves. Modern formulations may last longer still. Over millions of years, however, even concrete would weather fracture and blur until it resembled nothing more than odd stone. Recognition would be uncertain at best. Metals. Durable in the short term, treacherous in the long. Iron rusts, copper tarnishes, aluminum oxidizes. Without protection, metal artifacts crumble within centuries. Buried deep in oxygen-free environments, some might survive, though twisted and corroded beyond easy identification. Imagine stumbling upon a lump of green-streaked copper ore in a fossil bed. Would you see a coin or just a rock? Plastics. Our most ubiquitous material might also be one of our most enduring. In landfills and seabeds deprived of sunlight, plastic can linger for astonishing spans. Over millions of years, it may not remain intact, but could transform into a kind of synthetic rock, a strange hybrid of polymer and sediment known even now as plastiglomerate. Future geologists may puzzle over such deposits without ever guessing they were once bags, bottles, and toys. Radioactive isotopes, perhaps the clearest and strangest marker of all. Certain isotopes do not occur naturally in significant amounts. They exist only through nuclear reactions. While many decay quickly, some like plutonium-244 or iodine-129 linger far longer half-lives, stretching into the millions of years. If discovered in unexpected layers, they might stand out as undeniable evidence of technological activity. And yet even here, time conspires against clarity. After tens of millions of years, even these signals might fade into background noise. Taken together, these are the fossils of civilization, not statues or monuments, but chemistry and fragments. They are stubborn enough to last, but subtle enough to be overlooked, easily misfiled as nature's own handiwork. And here lies the irony. Our most enduring legacy may not be the beauty of our art or the scale of our cities, but our waste. Shards, residues, isotopes, tiny scars in the planet's skin. If that is true of us, might it not also be true of anyone who came before? Even if monuments crumble and metals corrode, there is another kind of trace a civilization might leave behind: the transformation of landscapes. Agriculture, forestry, and the reshaping of ecosystems all leave scars that can outlast the hands that made them. Consider the soil. Human farming has stripped nutrients from vast regions, compacted earth beneath heavy plows, and altered the chemistry of fields with fertilizers. These changes seep deep, embedding themselves in layers that may persist long after the crops are gone. Archaeologists studying ancient fields in the Near East can still detect differences in soil composition thousands of years later. Now imagine those signals magnified across continents, endured for millennia, and then fossilized subtle fingerprints left in the very dirt. Deforestation is another mark. In Europe, pollen records from lake sediments reveal the great clearances of the Middle Ages, when forests gave way to farmland. In the Amazon, black soils known as terra preta, rich fertile patches created by indigenous peoples, remain as testimony to cultivation practices more than 2,000 years old. Even where the jungle has swallowed everything else, the soil remembers. Our modern agriculture, vast and mechanized, leaves even deeper traces. Monocultures reduce biodiversity, replacing complex ecosystems with a single species over huge areas. Irrigation alters river systems, salinizing soil and reshaping water tables. Livestock change the balance of vegetation, shifting landscapes on scales visible from satellites. And these changes are not ephemeral. Even if fields are abandoned, it can take centuries or millennia for ecosystems to recover, and sometimes they never fully do. Imagine a forgotten civilization whose agriculture spanned millions of acres. Over time, their ploughed fields might revert to wilderness, their terraced hillsides collapse into slopes, but in the soil itself, in the pollen record, in subtle chemical residues, the memory of their presence could persist. Layers of sediment might reveal sudden declines in tree pollen, replaced by grasses or crops. Traces of charcoal might whisper of deliberate burning. Even long after tools and cities were gone, the earth would still carry their ecological shadow. This is what makes agriculture so powerful as a marker. Unlike monuments, it cannot be erased by simply abandoning it. It reshapes the planet itself, its soil, its rivers, its forests, and those scars, faint though they may be, can endure far longer than stone. If a civilization once tilled the earth millions of years ago, its ruins might be dust, its stories lost. But perhaps its ghost lingers not in monuments, but in the dirt beneath our feet, in patterns we have not yet learned to recognize. To understand how civilizations might vanish without a trace, it helps to imagine our own disappearance. Suppose that tomorrow, without warning, every human being were gone. No disaster, no firestorm, just absence. What would the earth look like a year from now, 100 years, a million? In the first days, little would change. Cities would remain lit until power plants ran out of fuel. Cars would sit where they were last parked. Airplanes would rest on runways silent but intact. But without us to tend them, the systems that keep our world running would begin to fail almost immediately. Water pumps would stop, electrical grids would cascade into darkness. Subways in New York or Tokyo would flood within days. Within years, nature would press its advantage. Weeds would push through cracks in asphalt. Roots would buckle sidewalks. Birds and animals long kept at bay would reclaim the streets. Wolves and bears would prowl suburbs. Deer would graze into the shadows of skyscrapers. The line between city and wilderness would blur quickly. Steel would rust. Glass would shatter. Concrete would weaken as rebar corroded within. In wetter climates, tall buildings would collapse within a century or two. Roads would fracture and fade beneath soil and vines. Satellites in orbit would wink out one by one, their solar panels failing their orbits, decaying until they burned up as streaks of light in the night sky. After 1,000 years, only ghosts of our presence would remain. The outlines of cities might still be faintly visible from above, especially in deserts where sand preserves shapes. In other regions, forests would have closed over everything, turning boulevards into green corridors. A few monuments, Mount Rushmore, perhaps the Great Pyramids, might still cling to existence, but even they would be weathered, cracked, eroded almost beyond recognition. 10,000 years on the planet would look much as it did before us. Coastlines would shift, deserts would migrate, glaciers might advance or retreat. Whatever remained of our buildings would be buried under layers of sediment, their meaning unreadable. And after 1,000,000 years, nearly all would be gone. Only the most stubborn traces would persist, pockets of synthetic molecules, residues of plastic compressed into plasticlomerate, faint isotopic anomalies from our burning of fossil fuels, radioactive signatures from nuclear tests. These would be the real fossils of our time. Not cities, not art, but chemistry. To any future species, they might look like nothing more than curious anomalies in stone. This thought experiment is sobering. If even our vast global civilization could disappear so quickly, leaving only scattered chemical scars, how can we expect to find certain traces of a civilization that may have risen and fallen tens of millions of years ago? Our fragility is not unique. It is the default. To search for civilizations lost beyond memory, we must learn to read the planet in its own language. Deep time does not speak in dates or dynasties. It whispers through stone, ice, and sediment. Its vocabulary is not kings and empires, but isotopes, pollen, and minerals. Scientists recover this language by drilling cores along cylinders of mud from the bottoms of lake sediments, from the ocean floor or ice, pulled from Greenland and Antarctica. Each layer is a page laid down slowly, sometimes grain by grain, sometimes in catastrophic bursts of ash or flood. Within these thin bands, the planet records itself, carbon trapped in bubbles, of ice pollen, grains that tell which plants once grew, magnetic minerals aligning with Earth's shifting field. From these fragments, whole climates are reconstructed. We know when glaciers waxed and waned, We know when deserts spread and when forests retreated. In some cores, volcanic eruptions leave black layers rich in ash. In others, asteroid strikes show themselves as sudden spikes of rare metals like iridium. The Paleocene-Eocene thermal maximum 56 million years ago left behind a sharp carbon anomaly, a planetary fever written into sediments across the globe. This is the language of geology ratios of carbon. 13 to carbon-12 shifts in oxygen. Isotopes, sudden appearances or disappearances of tiny fossils that once floated in oceans is not a full story, but a code one that must be interpreted. An interpretation is never simple. A spike in carbon could mean massive volcanic outpourings or the burning of fossil fuels by intelligent hands. A sudden drop in biodiversity might signal an asteroid strike or ecological collapse triggered by industry. The trick is context. A single clue means little. But when patterns converge, carbon anomalies paired with unusual metals extinctions paired with synthetic molecules, then suspicion grows. Just as detectives rarely solve mysteries with one piece of evidence, geologists must assemble a mosaic from scattered hints, each one fragile, each one incomplete. The Earth has written its story patiently, but is a cryptic diary full of gaps and smudges. To read it requires humility because the same signals that might betray a civilization could just as easily come from fire flood or volcano. And yet if there were ever ghosts of intelligence older than humanity, this is where they would speak, not in monuments above ground, but in chemical syllables etched quietly into the rock. Here lies the greatest difficulty. The Earth's archives are noisy. For every chemical spike or isotopic shift that might suggest intelligent activity, there are countless natural processes that can produce the same effect. To distinguish civilization from catastrophe, we must learn to separate deliberate signal from planetary static. Take the Paleocene-Eocene thermal maximum 56 million years ago. In sediments around the world, geologists find a sudden surge of carbon, a spike that resembles the one humans are creating today. Temperatures soared, oceans, acidified species vanished. To us it looks eerily familiar. But no cities stood then, no factories burned coal. The culprit was almost certainly natural volcanic eruptions, methane bursts, or some combination still debated. A pattern that looks like industry may in truth be geology. Or consider the thin layer of iridium found in rocks worldwide, marking the end of the dinosaurs 66 million years ago. At first, it was an enigma. Iridium is rare on Earth, but common in asteroids. Only later did scientists connect it to the Chicxulub impact. Without that context, it might have been dismissed as an odd quirk, another unexplained anomaly. Even more recent puzzles remind us how easily signals blur. The Younger Dryas. A sudden return to near Ice Age conditions about 12,800 years ago has been linked by some to a comet impact, by others to shifting ocean currents. Debate continues because the evidence is ambiguous. Was it nature's violence or something else? This ambiguity is the scientist's constant companion. Volcanism can mimic carbon-burning industries. Massive algae blooms can leave chemical residues that resemble synthetic processes. Shifting climates can erase distinctions, blending one cause into another. The planet has many ways to create chaos in its record, and only rarely do we get the clarity of a smoking gun. And so we must tread carefully. To declare a signal artificial, we would need more than one anomaly. We would need patterns layered together. Carbon shifts paired with metals, biodiversity collapse, paired with synthetic molecules, isotopes appearing in places they should not be. Only in concert could they begin to whisper of intention. But here is the haunting thought. What if such patterns already exist in our records, dismissed as coincidence or unexplained natural events? What if the signals are there, buried in the noise, and all that prevents us from seeing them is the narrowness of our questions? In science, caution is wisdom, but in caution too there is blindness. The Earth has always been noisy. The real challenge is whether somewhere within that roar, a faint voice has already tried to speak. If land is an imperfect archivist, the ocean is far worse. More than 70% of Earth's surface lies beneath water, and beneath that water is a record constantly erased, rewritten and swallowed whole. For any civilization that lived near coasts or worse upon the sea itself, the odds of survival are vanishingly small. Consider how often human societies have favoured shorelines. Ancient Egypt rose on the banks of the Nile, Mesopotamia, on the fertile floodplains between rivers, the Minoans, on the islands of the Aegean. Even today, most of humanity lives near oceans. It makes sense coasts offer food trade and temperate climates, but they are also fragile. Sea levels rise and fall with ice ages submerging whole landscapes. 20,000 years ago, much of what is now seafloor was dry land. Europe was connected to Britain by the fertile plains of Doggerland, a world now drowned beneath the North Sea. In Asia, the land bridge of Beringia once stretched between Siberia and Alaska, hosting forests and wildlife before the rising seas erased it completely. These examples are recent, measured in thousands of years, yet already almost unreachable. Imagine the effect over millions. Sediments accumulate relentlessly on the ocean floor, burying whatever lies beneath. The weight of water and mud crushes, distorts and dissolves remains until nothing recognizable is left. And even that is temporary, because the seafloor itself is young. Through the process of subduction, ocean crust slides back into the mantle along tectonic boundaries recycled as magma. The average age of seafloor is just 200 million years. Everything older has already been consumed. This means that if an ancient civilization lived along coasts or islands in deep time, their traces are almost certainly gone. Ports, harbours and seafaring technology, if they existed, would have been dismantled molecule by molecule, drawn down into the furnace of the earth. Even monumental structures, had they been built, would have lasted only as long as it took for waves to scour them and tectonic plates to reclaim them. And yet the ocean holds temptations. From time to time, archaeologists discover submerged ruins in shallow seas, stone temples off the coast of India, lost harbours around the Mediterranean. These are young recent by geological standards, but they remind us how easily the sea can conceal. How many other worlds might have slipped beneath the waves, erased beyond hope of recovery? If we are searching for the ghosts of deep civilizations, we must accept this limitation. The oceans are not just vast, they are editors with no interest in preservation. Their work is erasure, which means that the most likely places to hide a record of forgotten civilizations may not be the oceans where they thrived, but the rare corners of land where sediments, luck and geology conspired to resist the tide of time. Given how little survives, it is no wonder science approaches this question with caution. To suggest that another civilization once existed is to make an extraordinary claim, and science demands extraordinary evidence. Without it, the safer explanation is always nature. A carbon spike volcanism, a mass extinction, an asteroid, strange minerals, a quirk of chemistry, and often these answers are correct. This conservatism is not a flaw, but a safeguard. It prevents us from wandering into myth, from mistaking imagination for discovery. History offers many warnings, claims of out-of-place artifacts that prove to be hoaxes or misunderstandings. Elaborate tales of lost continents spun from little more than coincidence. Atlantis mu Lemuria. Romances born of human longing rather than data. Science resists these temptations because its strength lies in restraint. And yet this very humility leaves open a curious possibility. What if traces of an earlier civilization already exist, but we have passed them by dismissing them as natural anomalies because we lack the framework to see them otherwise? After all, the iridium layer at the end of the Cretaceous was once a puzzle without meaning. Only when the idea of an asteroid impact was proposed did the data suddenly fit into place. Until then, it was just a chemical oddity. Context transformed noise into the signal. This is why thought experiments like the Silurian hypothesis matter. They do not prove that anyone came before us. Instead, they sharpen our awareness of what we might overlook. They remind us that the geological record is patchy, noisy, and deceptive, and that our interpretations depend not only on what we find, but on the questions we are willing to ask. There is humility too in turning the question back upon ourselves. If we, with our global industry and billions of voices, could vanish in a geological instant, what would survive of us? And would some future intelligence tens of millions of years from now recognize our signals or dismiss them as natural curiosities? Science teaches caution, but curiosity endures. Between those two poles lies the space of wonder, the willingness to admit that absence of evidence may not always be evidence of absence. Perhaps we are alone the first and only to rise. Or perhaps we are only the latest draft in a story the Earth has written and erased many times before. So we return to the question that has hovered like a shadow through all these layers of time. What if we are not the first? The answer, if there is one, is buried deep, scattered in fragments disguised as nature itself. Perhaps there was nothing before us, only the long silence of oceans, forests, and stone. Or perhaps, once another intelligence rose briefly lived, and was swept away, leaving no monument but a chemical whisper in the rock. The Earth has no obligation to remember. It has erased continents, drowned valleys, melted mountains, recycled oceans. Against such forces we are fragile. Our cities, our machines, our stories, all will vanish. 1 million years from now, there may be little left of us but a thin layer into the sediment, a strange signal in the chemistry, the faint residue of fire and plastic. That is the scale of deep time, patient, thorough, merciless. But there is also a kind of beauty in this realization, for it reminds us that we are not as permanent as we believe and that our time is precious. If others came before us, they too dreamed, struggled, loved, and wondered. They too looked at the sky and asked questions that had no certain answers. Their silence now is not proof they never existed. It is proof of how easily time erases even the brightest flame. And so the deeper lesson is not about whether a forgotten civilization truly lived millions of years ago. It is about humility. It is about recognizing that we are temporary guests on a planet older and more powerful than we can fathom. Our legacy will not be measured in monuments, but in the marks we leave on the Earth itself. Chemical, ecological, biological. Perhaps one day far in the future another intelligence will sift through the layers we have written and wonder about us. Perhaps they will see the spikes of carbon, the sudden loss of species, the fragments of polymers turned to stone. Perhaps they will pause. As we pause now and ask the question we cannot answer, were we the first or only the latest? For now, the truth remains out of reach. The Earth keeps its secrets well, and yet in the silence the question endures, calling us to curiosity, to wonder, to the fragile recognition that we too are part of a story that stretches far beyond our comprehension. Part 1. The fragility of time underwater. What happens to structures over deep time? Wood splinters, rope unravels, stone cracks, and collapses, and metal corrodes with alarming speed when surrounded by salt water. Even the mightiest column, once proud and upright, dissolves into rubble as the ocean patiently works at its edges. Unless something is entombed quickly under sand or silt cut off from oxygen, the odds of survival plummet. A city, no matter how advanced, stands little chance of remaining intact for more than a few thousand years beneath the waves. Millions, almost unimaginable. The sea is not a museum. It does not preserve, it dismantles. Consider a wooden ship of the age of sail. Left abandoned in a shallow bay, its timbers are devoured by shipworms, its iron fittings rust into flaky red scars, its ropes loosen into threads carried away by the tide. This happens within decades. Stretch that decay across centuries and the ship all but disappears. Now extend the scale further to millennia, to millions of years. The ocean floor becomes less a resting place than a churning mill, grinding and recycling every trace of what once was. Archaeologists know this all too well. The wrecks they recover are almost always recent by geological standards. Even Roman harbours built of ingenious hydraulic concrete are now cracked reefs colonized by barnacles and fish. And these are sites only a few thousand years old, barely a heartbeat in Earth's chronology. Imagine something built not 10 centuries ago, but 10 million. The odds of any recognizable remnant surviving are close to zero. And yet the possibility lingers in the imagination. Because coasts are where civilizations begin. The shoreline offers fertile soils, trade routes, fish, and a steady supply of salt. Ancient peoples lived with the sea as their pantry, their road, their protector. But they also knew it as a thief. In myths from Ireland to India, the ocean is described not just as bountiful, but as hungry, always ready to reclaim what humans dared to build too close to its edge. Even today we see echoes of this fragility. Entire fishing villages along the English coast have slipped into the waves in a single storm season. On the islands of Micronesia, stone cities like Nan Madol still stand, but the encroaching Pacific gnaws at their walls. These modern examples give us a chilling glimpse of how the sea operates in deep time, patient, merciless, inevitable. So when we wonder whether ancient structures might survive in the depths, the answer is almost always the same. Unless nature herself intervened to bury them swiftly in protective layers of silt, they would not. And even if they did, they would be nearly impossible to detect without advanced scanning of the seabed. The ocean does not keep memories in stone columns or marble streets. It swallows them, grinds them, and disperses them until they are indistinguishable from natural rock. And this is where the haunting thought emerges. If a civilization once flourished long before us building, trading, fishing, perhaps even exploring what remains of it now, perhaps nothing more than a faint trace hidden beneath layers of sand or a chemical shadow buried in sediment. From the surface, the sea offers only silence, a silence that feels less like absence and more like deliberate forgetting. This part focuses on anomalies and the ocean's deceptions, how geometric features in the seabed can tempt us into thinking they're artificial, why nature can mimic human design, and examples of real misinterpretations. Anomalies and the ocean's deceptions. When people imagine lost cities beneath the waves, they picture crisp outlines, avenues of stone-perfect right angles, grand staircases descending into the abyss. And in theory, artificial structures could leave such geomorphological traces, straight lines repeating shapes patterns that scream intention rather than accident. But the ocean is a master illusionist. It shapes rock into geometry that looks deliberate, but is nothing more than geology playing tricks on the eye. Basalt columns born of cooling lava rise in uncanny hexagons, as if laid by careful engineers. Sandstone cliffs fracture into squares and rectangles mimicking the outlines of city walls. Even coral reefs sometimes grow into perfect circles or spirals, architectural in appearance but entirely biological in origin. When mapped with sonar, these forms can resemble plazas walls or even entire grids. To the hopeful eye, they look like Atlantis. To the geologist, they are merely the patient handiwork of Earth's natural processes. This is why so many underwater anomalies that ignite public imagination eventually dissolve into disappointment. In the early 2000s, divers investigating the so-called Yonaguni Monument off the coast of Japan claimed to have found a sunken city, massive platforms, terraces, even steps descending into the sea. Photographs seemed to confirm it a lost temple, a forgotten citadel. But further study revealed that tectonic activity and wave erosion were sufficient to explain the sharp edges. The monument was not carved by hands but sculpted by time. A similar story surrounds the Baltic Sea anomaly discovered by sonar scans in 2011. Headlines screamed of a UFO resting on the seafloor, a perfect disk 50 feet across. But subsequent investigations suggested glacial activity as the more likely culprit. The disk was a natural formation, its symmetry a coincidence magnified by our human desire for patterns. And that desire is powerful. Our minds are tuned to recognize order in chaos, to see faces in clouds and cities in rocks. In the uncertainty of the deep ocean, this instinct amplifies. A blurred sonar image becomes a wall, a crack becomes a doorway, a cluster of rocks becomes the ruins of a plaza. This isn't to say we should dismiss anomalies outright. Genuine discoveries often begin with something odd, something out of place, but the lesson of the ocean is caution. Nature is not random. It creates regularity, repetition, and structure on its own. Without context, without artifacts, cultural debris, or supporting evidence, geometry alone cannot prove civilization. It can only remind us how easily the sea deceives, and so we circle back to the same question. If we stumbled upon the traces of a civilization erased by millions of years, would we even recognize it? Or would we file it away as another trick of geology, another anomaly explained by natural forces? The answer is unsettling. Perhaps the proof has already been seen, only to be dismissed, forgotten, or mislabeled as just another rock. Civilization and the sea? What if a civilization did not merely live near the ocean, but used it with the intensity we do today? The coast is always an invitation, a frontier for food, for trade, for power. For us, it has become an industrial engine. Fishing fleets harvest billions of tons annually. Tankers and cargo ships crisscross the seas in endless lines visible from satellites as white scars in blue. Oil rigs punch into the seabed pipelines, yet snake across continental shelves, and waste chemical, radioactive and plastic flows daily into the currents. The sea is no longer only the world's pantry. It is our landfill, our factory, our testing ground. If an earlier civilization existed and reached a similar stage, they too might have left signals, not monuments, or machines, but geochemical scars. Our oceans already carry the massive gyres of plastic drifting like synthetic continents, mercury and lead traced in the flesh of deep-sea fish, radioactive isotopes scattered from mid-20th century weapons tests, fertilizer runoff choking coastal waters into dead zones, and microplastics that sink with marine snow into the trenches of the Mariana. Each of these markers is a kind of chemical graffiti, written into layers of sediment that may last tens of thousands of years. It is a searing thought. Our skyscrapers may collapse, our digital archives may fade, but fragments of plastic shopping bags and the isotopic fingerprints of nuclear fallout will still whisper our presence to whatever eyes or instruments may examine this planet far in the future. If a forgotten civilization had once burned coal or smelted metals, if they too had poured waste into the sea or seeded it with synthetic molecules of their own invention, could those traces persist today, perhaps? Yet they would be subtle, buried under miles of water and layers of shifting sediment. And even if uncovered, they would not announce themselves as artificial at first glance. They would look like chemistry, like anomalies in a dataset. This is why the question is less about whether such traces could exist and more about recognition. Would we even realize what we were looking at? Imagine a spike of carbon dioxide preserved in sediment from 20 million years ago. Would we see it as evidence of industry or dismiss it as another volcanic episode? The haunting possibility is that the signal of a past civilization might already be present in our geological archive, sitting unrecognized in samples labeled unusual, waiting for someone to look again with a different question. And until that question is asked, the ocean keeps its secrets. This part is about the lost tech test, whether technology could survive over millions of years, what kinds of materials might endure, and how subtle those traces would be. The lost tech test. This is the heart of the challenge, what you might call the lost tech test. Could the technological activity of a long-vanished civilization survive in a way that's still legible today? And if it did, would we recognize it or dismiss it as another geological quirk? Modern humanity has already scattered potential clues for the deep future. Synthetic molecules like plastics and industrial chemicals are unlike anything in nature. Their structures are artificial, resilient, and alien to the natural chemistry of Earth. Some break down quickly under sunlight or oxygen, but buried in oxygen-poor sediments, fragments could last for hundreds of thousands of years. Imagine in some distant epoch a geologist splitting a rock and finding a vein of polymerized residue, brittle, translucent, and incomprehensible. Would they guess it was once a shopping bag, a bottle cap, or a fishing net? Or would it be classified as a strange but natural compound? But plastics are only part of the story. Human industry has also produced entirely new minerals technofossils. Concrete aluminum alloys fly ash from coal combustion, glassy byproducts of smelting. These substances don't occur naturally, yet we're creating them in such vast quantities that some geologists believe they will define the Anthropocene in the rock record. To an investigator millions of years from now, a thin layer of concrete dust or slag embedded in sediments might be the clearest sign that something artificial once walked this earth. There are also radioactive markers. The mid-20th century scattered isotopes like plutonium-239 and cesium-137 across the globe, seeding soils, oceans and bones alike. These isotopes decay but not quickly. Some persist for tens of thousands of years. Their sudden appearance in geological layers, then disappearance, would look like a sharp global anomaly with no volcanic or cosmic explanation. It would scream event. But would it scream civilization? Not necessarily. It would require interpretation context that may be lost. Even heavy metals and rare earth elements mined and concentrated by humans could survive as signatures. Unusual enrichments in sediment layers might suggest processing or pollution, but again, nature also concentrates these elements through volcanic vents and hydrothermal activity. Without supporting evidence, the signal is ambiguous. The deeper truth is this: the problem isn't that traces of technology can't exist, is that they don't immediately declare themselves as artificial. They look like chemistry. They look like subtle scattered disturbances against a noisy background. Unless they come paired with obvious artifacts, geometry tools, inscriptions, they remain anomalies, not proof. This is what makes the lost tech test so humbling. Even if another civilization had risen, built, burned, and vanished tens of millions of years ago, its legacy might now be reduced to little more than a faint chemical spike, a peculiar layer in stone, or a mineral that shouldn't be there. Evidence that whispers instead of shouts. And whispers, as history shows, are easy to overlook. Patterns versus artifacts. One fragment is never enough. A shard of glass in the dirt could be the remnant of a bottle or a quirk of natural crystallization. A smooth stone could be a tool or simply a pebble worn by the river. Archaeology teaches us this with relentless clarity. What matters is not the single find, but the pattern. Only when repetition appears, clusters of artifacts, consistent markings, deliberate wear, does a story begin to emerge. This is why searching for traces of lost civilizations in deep time is so daunting. A lone piece of plastic buried in sediment millions of years old would be meaningless without context. It could be intrusion, contamination, a misdated layer. But a consistent distribution of plastics across regions appearing abruptly in the geological record that would demand attention. It is pattern, not anomaly, that elevates coincidence into evidence. History itself offers an instructive parallel. For decades, archaeologists dismissed many stone fragments as mere geofacts, naturally broken rocks. Only later, when identical shapes were found across continents bearing the same striking angles, the same wear from repeated use, did the picture change. What once looked random became unmistakably deliberate, the first flint tools of early humanity more than 2 million years old. Even then, recognition took time. The human mind resists conclusions that challenge its expectations. In the 19th century, when Boucher de Perthes presented evidence of ancient stone tools alongside the bones of extinct animals, he was ridiculed. Only when patterns multiplied and other scientists confirmed them did the idea of deep prehistory gain acceptance. One tool could be dismissed, hundreds could not. The same principle applies to the search for vanished civilizations. A metallic anomaly in one sediment core might be shrugged off as contamination, but a systematic layer of heavy metals appearing globally at the same horizon would be something else entirely. It would suggest not accident but process, not nature alone but agency. And yet, even with patterns, interpretation remains slippery. The Earth itself produces repetition. Volcanic eruptions scatter ash layers across continents. Asteroid impacts leave worldwide blankets of debris. Natural cycles can mimic the signals of technology. The key lies in distinguishing the two, something far harder than it sounds, especially across spans of tens of millions of years. So the paradox emerges: the traces of technology may be most visible not in artifacts but in patterns of absence or distortion. In sediments missing expected minerals. In isotopic ratios that do not align with any known natural process. These are fragile signals, easy to misread, easy to dismiss. And that is perhaps the greatest danger of all. Not that we lack evidence, but that we may already have it scattered, subtle, misclassified, and never think to look again. Heavy metals and rare earths. If there is one hallmark of technological civilization, it is the way it concentrates what nature has scattered. We mine copper from distant hills, iron from deep veins, gold from riverbeds. We refine, smelt alloy, and discard. In the process, we leave behind a chemical footprint unlike anything found in untouched geology. Sediments rich in lead-mercury or rare earth elements tell a story not of nature slowly distributing resources, but of human hands gathering, using, and wasting them in unnatural abundance. Now imagine looking for such signals in deep time. Could we tell the difference between volcanic enrichment and industrial waste? The line is thin. Volcanic systems produce their own surges of metals, copper, arsenic, manganese, all concentrated through heat and pressure. Hydrothermal vents on the ocean floor emit plumes rich in rare earths, creating deposits as striking as anything human industry has left behind. The challenge lies in ratios. Natural processes produce metals in certain balances. Industrial ones disrupt those balances. Lead levels in Roman ice cores, for instance, spike sharply during the height of Roman mining and smelting so distinct that modern scientists can track the rise and fall of Roman economic activity through Greenland's ice. That is the power of a chemical signal, fragile as memory, yet precise as a ledger. Our own era has produced even starker signatures. Electronic waste piles high with cobalt, tantalum, and neodymium, rare earth elements pulled from scattered ores and concentrated into circuit boards, magnets, and batteries. When discarded, these materials seep into soils and waters, sometimes forming toxic hotspots around landfills and rivers. Future geologists might see these anomalies as sudden localized enrichments of elements that should otherwise remain scarce. If a civilization before us ever mined and refined on a large scale, their wastes might look similar. Scattered but unnatural pockets of rare elements embedded in sedimentary layers. But again, in interpretation, this is the stumbling block. A future researcher might call it hydrothermal activity or volcanic redistribution, never considering the possibility of industry. The traces would be there, just explained away. There is also the matter of what disappears. Mining is not only about adding metals, but about taking them out. A region once rich in a mineral might suddenly lack it, not because nature removed it, but because a civilization did. But how do you detect an absence millions of years later? The empty veins are buried, the missing material dispersed, the story dissolved into the larger churn of Earth's geology. And yet there are whispers. In the modern world, we see how persistent these signals are. The mercury from 19th century gold mining still poisons rivers in California. The cadmium from industrial runoff lingers in the soils of Japan. The scars of extraction, though softened by time, never fully heal. If a lost civilization reached even a fraction of our technological hunger, they too would have scarred the Earth with metals. The question is not whether the traces could exist, but whether anyone would ever read them for what they are. Energy and invisible signatures. Every civilization that rises beyond subsistence begins to hunger for energy. It is energy that turns fields into cities, rivers into highways, sparks into machines. But energy also leaves waste heat, smoke, ash, and emissions that seep into air, soil, and sea. For us, this is a defining feature of the Anthropocene. For any civilization that came before it, might have been the only signal strong enough to persist. Think of what our own consumption has done in a blink of geological time. Coal smoke blackened skies and settled as soot in glacial ice. Oil combustion poured carbon dioxide into the atmosphere, pushing concentrations higher than at any point in millions of years. Nuclear fission scattered isotopes into soils and oceans, their fingerprints now measurable on every continent. Even thermal pollution waste heat from power plants and industry has changed. Local water temperatures altered currents and stressed ecosystems. These are the marks of our age, not cathedrals or skyscrapers, but chemistry. Now imagine an earlier civilization burning its own fuels. Perhaps coal, perhaps something we cannot conceive of, biofuels, chemical reactions, geothermal, harnessed at scale. Whatever their method, the byproducts would not vanish quietly. Carbon dioxide from combustion is absorbed by the ocean, altering pH levels and leaving behind subtle but detectable shifts in isotopic ratios. Methane leaks change atmospheric chemistry. Radioactive byproducts seed sediments. Each layer of ocean floor becomes a page marked with the energy story of its time. We already know this story is legible. The Fukushima disaster in 2011 sent radioactive isotopes coursing across the Pacific. Within months, scientists measured them on North America's shores. In ice cores, volcanic eruptions show up as thin black bands, evidence of sudden global change. If our activities can be tracked so clearly in decades, what might a civilization's energy use look like if it lasted centuries or millennia? And yet here lies the problem: none of these traces immediately scream civilization. A carbon spike could be volcanism. Radioactive anomalies could be cosmic rays. Heat signatures could be shifting currents. Without context, they are just oddities, and oddities are easy to dismiss. The paradox is haunting. To leave a signal strong enough to survive, a civilization must alter the planet dramatically. But the stronger the alteration, the more likely it is to resemble natural disasters, volcanoes, impacts, floods. Their story would hide in plain sight, disguised as geology. We are left with the unsettling possibility that somewhere in Earth's layered memory there already is such a spike, such a signature, and that we have measured it, logged it, and moved on, never imagining it might be the echo of minds that once burned as brightly as ours. The ocean as a razor. When people speak of cities lost to the sea, they reach for names half made of legend: Atlantis, Lemuria, whole continents imagined beneath the waves. These tales persist because the ocean itself is such an effective stage for mystery, vast, opaque, and unknowable. But the truth is colder. The real ocean has indeed swallowed real cities, and none of them left monuments gleaming in the deep. The sea does not preserve, it erases. Slowly, relentlessly, without pause. A temple toppled on land might linger for centuries, its pillars leaning, its carvings weathered, but legible. Submerge it and the same temple becomes unrecognizable in decades. Salt water seeps into stone mortar, crumbles, carvings fade. Marine organisms colonize surfaces, drilling, boring, eating away at the very structure. What the sea takes it does not hold, it digests. Take Alexandria, where Cleopatra's palace once stood. Earthquakes and rising waters buried it beneath the harbour. Today, divers exploring its ruins find scattered blocks, tumbled statues, columns lying like broken bones on the seabed. The outlines of grandeur are there, but blurred, softened, almost gone. Caesarea Maritima. Herod's great harbour in Judea, built with revolutionary concrete that hardened underwater, is now a field of ruins, more reef than city. Nanmadol in Micronesia, though not yet claimed by the sea, is crumbling as tides reclaim its canals. And these are young ruins, a few thousand years old, at most recent enough to still be recognized. Push further back and the ocean gives nothing. 10,000 years and the outlines blur. 100,000 and the last walls collapse. 10 million and even the memory of architecture dissolves into geology. Yet myths endure. Why? Perhaps because people across cultures witnessed this erasure firsthand. In Ireland, stories tell of Lyonesse, a kingdom drowned beneath the sea. In Wales, of Cantre'r Gwaelod, a land swallowed by the tide. In India, of cities dragged into the water by angry gods. These tales may be allegory, but they may also be memory, cultural echoes of coastlines that shifted, lands that vanished, worlds reclaimed. The lesson is as humbling as it is chilling. If a city falls into the ocean, what remains after millennia is not a monument but silence. A silence shaped not by chance but by the nature of water itself. The sea is not an archive. It is an eraser, steady and patient, turning human ambition into silt, shifting coastlines and human fragility. Civilizations have always gathered by the sea. The reasons are obvious. Fertile deltas where rivers meet saltwater harbors that welcome trade, predictable weather, tempered by the ocean's breath. But by building on the edge of the land, humans unknowingly build on the edge of permanence. Coastlines are not boundaries, they are negotiations. They move, collapse, rebuild. What looks eternal in a single lifetime is only a passing phase in the language of geology. During the last ice age, vast sheets of ice locked away water and global sea levels stood over 100 meters lower than today. What is now seabed was then dry land. People walked where fish now swim. When the glaciers melted, seas surged forward, swallowing valleys, plains and settlements. It was not sudden everywhere, but to those who lived through it, it must have felt apocalyptic. A field one generation had farmed might become marshland in the next. A village by the shore might vanish under rising tides within memory. Even without ice, the land itself breathes. Earthquakes can drop entire coastlines in minutes, as happened in Chile in 1960 when the ground sank by 2 meters, submerging forests. Volcanoes can build new land even as they bury old. Rivers shift course, starving some deltas while feeding others. And beneath it all, tectonic plates drift, lifting and drowning continents in cycles far longer than any civilization can survive. This instability has always left its mark on culture. Fishermen in the North Sea still speak of Doggerland, a memory of plains once stretching between Britain and Europe, now hidden beneath waves. Oral traditions from the Pacific Islands tell of ancestors retreating inland as the ocean crept higher, carrying their homes with them. Myths of drowned lands are not just fantasy, they are lived experiences passed down through memory, transformed into story. For modern humans, the lesson is visible in real time. Jakarta sinks by centimeters each year, its buildings leaning into the rising Java Sea. Miami builds seawalls against tides that grow stronger every decade. Entire nations like Tuvalu and Kiribati face the possibility of disappearance within a human lifetime. We are watching with satellites and tide gauges what our ancestors once watched with their own eyes, the slow migration of the coast indifferent to human need. If civilizations before us also built on these fragile borders, their fates would have been the same. Their streets drowned, their fields salt-stained, their temples toppled not by conquest but by the patient advance of water, and with each inundation the record of their existence would fade until only story, rumour and silence remained. Case study Dwarka and Pavlopetri. Among the most evocative names whispered in discussions of lost cities is Dwarka, a site off the coast of India. Divers exploring the shallows near modern Dwarka have found stone structures, walls, and what seem like the outlines of streets beneath the tide. Some claim it is one of the oldest submerged cities in the world, a remnant of the legendary kingdom described in Hindu texts. The excitement was immediate here, perhaps was proof that myth and archaeology overlapped. Yet the evidence remains contested. The stones may indeed have been arranged by human hands, but erosion, biological incrustation and centuries of waves have blurred their edges. Are they remnants of a real settlement or natural formations shaped into deceptive regularity? The debate continues as it so often does with ruins claimed by the sea. Then there is Pavlopetri off the coast of Greece. Unlike Dwarka here, the outlines are clearer stone foundations forming recognizable rooms, streets and courtyards. Archaeologists believe the site dates back to at least 5,000 years ago, making it the oldest known submerged city with a confirmed urban plan. And yet what remains today is fragile, a scattering of walls barely a metre high, worn smooth by waves overgrown with seaweed, more suggestion than monument. Further north, the Doggerland region beneath the North Sea tells a quieter story. Once a vast plain connecting Britain to mainland Europe, it was home to Mesolithic peoples who hunted, fished and built along its rivers. As sea levels rose after the last ice age, Doggerland disappeared beneath the waves. What remains are fragments dredged from the seabed tools, bones, and traces of a vanished landscape. No standing structures, no cities, just hints of lives erased by water. These examples matter because they are recent, mere thousands of years old, close enough that the sea has not yet erased them entirely. Even so, what survives is faint fragmentary, difficult to interpret. Stone blocks that may or may not be architectural, outlines that only make sense when traced from above, artifacts scattered, displaced, often discovered not in context but dredged from sediment by fishing nets. And here lies the sobering truth. If this is what we see after a few thousand years, what hope do we have of identifying anything older? Push back 10 times further, and erosion smears the record beyond recognition. Push back 1,000,000 years, and the ocean does not just bury, but erases. Doggerland Pavlopetri Dwarka. These are not monuments preserved by the sea. They are warnings, reminders of how swiftly the water dismantles even the most durable human endeavors, why underwater cities don't last. Even stone, humanity's most enduring material, cannot resist the sea forever. At first, walls tumble under the weight of shifting currents, their mortar dissolved grain by grain. Then the sharp corners begin to round off, smoothed by abrasion, as if the ocean is sculpting them into silence. Carvings fade as salt crystallizes in the cracks, prying them open, until detail is lost. What once bore human meaning becomes nothing more than texture. Biological life accelerates the process. Algae spread across surfaces, softening outlines beneath a green veil. Shellfish and barnacles anchor themselves to once proud columns. Worms burrow into limestone, riddling it with holes until it fractures. Corals colonize the ruins, transforming human architecture into reef. To divers, these sites may look vibrant, alive with fish, color and movement, but that very life is also the agent of erasure. The city becomes habitat, its identity consumed by other species. Over centuries, even massive blocks begin to crumble. Mortar dissolves, joints weaken, and pressure from waves turns walls into rubble. Over millennia, that rubble disperses into gravel, then sand. In time, the distinction between worked stone and natural rock vanishes. A toppled column may become indistinguishable from an underwater ridge. A collapsed house may resemble a natural rockfall. The sea has no interest in keeping the story straight. And that is just for ruins submerged in recent history. Stretch the scale into tens of thousands of years and almost nothing recognizable survives. Stretch it into millions and the record dissolves entirely. Sediment shifts, burying or grinding down whatever fragments remain. Tectonic activity tilts seabeds, uplifting or swallowing them into trenches. The slow chemistry of water and pressure breaks down even the most durable forms. What was once a city becomes indistinguishable from seabed geology. This explains why the dream of finding an Atlantis preserved in perfect marble beneath the waves is more fantasy than possibility. The ocean does not keep monuments, it dismantles them and folds their remains back into the planet's restless churn. What survives are not colonnades or plazas, but silence. And yet silence is deceptive, it invites speculation, invites story. For every vanished city there will be legends, rumours and hopeful eyes reading patterns into stone. That yearning is as enduring as any ruin, perhaps longer, because the sea erases stone but it cannot erase the human need to remember or to imagine what might have been. The ocean floor's hidden vastness. We often imagine the deep sea as if it were already charted, mapped in neat blue lines on our globes. But the truth is stranger and more humbling. We know the surface of the moon more intimately than the floor of our own oceans. Only a fraction less than a quarter of the seabed has been mapped in detail. The rest lies blurred guesstied at through indirect soundings, reduced to vague contours. What we picture as solid knowledge is in reality a shadow. When researchers map the ocean floor, they rely on sonar. Sound waves bounce off the seabed and return painting outlines of mountains, valleys and ridges. But the resolution is crude. Entire features the size of city blocks vanish into the noise. Small structures, a wall, a road, even a temple would be invisible. To find such things requires submersibles, high-resolution scanning and precise surveys. These are slow, expensive and limited. The deep sea resists casual exploration. Consider how recently some of the most dramatic discoveries were made. Hydrothermal vents, entire ecosystems thriving without sunlight, were unknown until 1977. The wreck of the Titanic, one of the most famous ships in history, lay hidden until 1985 despite countless attempts to locate it. And that was a steel vessel barely 70 years old resting in the North Atlantic, a region relatively close to human activity. If a single ship could remain elusive for decades, what chance do we have of finding the faint remains of a city erased by millennia? Even when we do scan, the scale of the search dwarfs us. The ocean floor covers over 3 million square kilometers. To survey it at the detail necessary to distinguish artificial structures from geology would take centuries, even with modern technology. Most expeditions focus on narrow slices, shipping routes, resource exploration, known wrecks. The vast majority remains untouched, unexamined, waiting. This is why so many claims of underwater cities come from shallow waters near coasts where divers and fishermen happen upon anomalies. We search where it is easy to reach, not where the mysteries likely lie. The deep trenches, the abyssal plains, the buried margins of continental shelves, All of these remain almost invisible to us. And yet if anything from a forgotten civilization survived, it would likely be there hidden in the least accessible places. The paradox is sharp. The ocean may conceal, but it also protects. A city swiftly buried by sediment in a stable environment might endure as a ghostly imprint. But to find it, we would have to know precisely where to look. Otherwise, it remains part of the unseen 75% of the world that we still cannot claim to understand. The question lingers: how much have we missed simply because we have not looked closely enough? And how many secrets still sleep beneath the black pressure of the abyss, waiting for an eye patient enough and curious enough to see them? Sediment cores as time capsules. If the ocean erases monuments, it also keeps a subtler record chemistry. Each year, dust ash plankton shells and eroded minerals settle onto the seafloor, layering grain upon grain into a quiet archive. Over millions of years, these sediments compress into stone, carrying within them the fingerprints of climate catastrophe and change. For scientists, drilling a core into the seabed is like pulling up pages from Earth's diary. Within these cores, we can read the rhythms of the planet. Shifts in oxygen isotopes tell us of ice ages advancing and retreating. Layers rich in iridium mark the impact of an asteroid 6 million years ago, the blow that ended the reign of the dinosaurs. Sudden dark bands of volcanic ash reveal eruptions so vast they dimmed the sky. Even the tiniest shells of plankton preserved like glass beads testify to ocean acidity and productivity long vanished. But cores do more than confirm what we expect. They sometimes confront us with anomalies. A spike in carbon that rises too quickly to match natural cycles. A thin stratum enriched in metals that don't belong. Abrupt warming events like the Paleocene-Eocene thermal maximum, when global temperatures surged by up to 8 degrees in less than 20,000 years. For decades, scientists have debated its cause: volcanism, methane releases, or something stranger. It is in these anomalies that imagination stirs. If humanity's industrial footprint were compressed into a thin geological layer, it might look like one of these sharp, sudden global. A carbon spike, a plastic-rich stratum, a scatter of isotopes. To us, the Anthropocene is unmistakable. But what if a similar spike lay buried deep in Earth's past? Would we see it for what it was, or would we fold it neatly into our catalogue of natural disasters? Sediment cores are tantalizing because they preserve continuity. They are less fragile than myths, less perishable than ruins. If an earlier civilization altered the oceans through energy use, waste, or chemical invention, its echoes could be entombed here. But the signals are subtle: a pattern in isotope ratios, a trace of synthetic-like molecules, a distribution of metals too precise to be volcanic. They whisper, but they do not declare. And perhaps that is why no core has yet given us certainty. The anomalies we find, carbon surges, isotopic shifts, are explained by natural forces, and rightly so. The burden of proof for intelligence is immense. But the cores remind us of possibility. They remind us that the ocean keeps every story, even those too faint for us to yet interpret. Somewhere in those quiet layers may rest the truest chronicle of what came before. The question is whether we will ever learn how to read it. The problem of subtlety. The problem is not that traces of technology cannot survive. The problem is that if they do not announce themselves. They whisper. A chemical spike in carbon dioxide, a thin layer enriched in metals, an unusual isotopic ratio. Each of these could be civilization, but each could just as easily be volcanoes, methane bursts, or cosmic impacts. The Earth is noisy, and the signals of life and catastrophe overlap. This is why anomalies are often treated with caution, even dismissal. A geologist drilling into a seabed core finds a stratum rich in nickel and chromium. The first conclusion will not be industry, it will be volcanism. If carbon dioxide levels soar, we assume greenhouse pulses. If isotopes shift abruptly, we assume meteorites. Nature provides ample explanations, and science is trained to choose the simplest one. And history shows how this conservatism cuts both ways. For decades, the idea of continental drift was dismissed, even ridiculed. Alfred Wegener's claim that continents moved seemed absurd without a known mechanism. The data fossil distributions matching rock layers was there, but it was not enough to overturn assumptions. Only later, when plate tectonics provided the missing explanation, did those dismissed anomalies reveal their true meaning. The same is true of the asteroid impact theory for the extinction of the dinosaurs. For years, the strange iridium-rich layer was noted but filed away as volcanic. Only when Lewis and Walter Alvarez connected the dots did the idea of a cataclysmic impact take hold. Again, the signal was subtle. Again, it was nearly lost. So what if the same is true of civilization? What if a stratum somewhere already holds a signature, subtle, ambiguous, easy-to-miss file, a spike of synthetic-like compounds we haven't recognized for what they are? A global anomaly explained away by volcanism because we cannot yet conceive of another cause. This is the danger of subtlety. The most extraordinary signals can look ordinary until context changes. They are not like carved statues or inscriptions. They are chemistry ratios absences. To recognize them requires not just data, but imagination, the willingness to ask whether what we are seeing could be more than geology. And yet imagination is risky. Without discipline, it slides into fantasy. Without rigor, it invents civilizations wherever there are oddities. The balance is delicate. Science must remain skeptical but not blind. Myths remind us to wonder, geology reminds us to doubt. Between them lies the space where truth might dwell, quiet, fragile, easy to miss. Which leaves us with an unsettling thought. Perhaps the signals are there, scattered through the cores and stones we already study. Perhaps the only reason we do not see them is because we have not yet asked the right question. The silence of sunken landscape. Every coastline carries two stories, one of flourishing, the other of erasure. Fertile estuaries and rich fisheries have always lured humans to the edge of the sea, but that same boundary is a fault line between stability and loss. To live on the coast is to live beside an eraser. The silence of submerged landscapes is not just geological, it is cultural. When Doggersland slipped beneath the North Sea, when Pavla-Petri was drowned, when fields in Bengal and Java vanished under rising tides, people were forced to move, carrying with them not bricks and stones, but memories. These memories reshaped into myth. Legends of drowned kingdoms like Lyonesse or Cantreur, Gwaelod speak less of grandeur and more of grief, a recognition that what was once home could vanish without warning. And it is not only myths of Europe or Asia. Across the Pacific, Polynesian stories describe islands eaten by the sea. In the Americas, native oral traditions speak of great floods that chase their ancestors inland. These stories echo across cultures not because of coincidence, but because of lived experience. To lose a homeland to water is so devastating, so absolute that memory refuses to let go. The archaeology of such places, however, is faint. The ocean gives no monuments, only fragments. A stone tool dredged from the seabed, a scatter of bones, a wall softened into a reef. These traces whisper that people once lived there, but they do not shout. They never shout. The dominant feature of sunken landscapes is not presence, but absence. And this absence has its own lesson. We tend to think of civilization as permanent, as something that accumulates like layers of stone. But the ocean shows us otherwise. What took generations to build can vanish in a single storm surge. What we think of as eternal foundations, columns, walls, harbours become silt and silence. Perhaps that is why the myths persist. They are not really about lost cities. They are about the fragility of presence. They remind us that permanence is an illusion humans invented to comfort themselves. The earth does not recognise permanence, the ocean least of all. So when we look out over the waves and imagine Atlantis, we are not really seeing marble palaces. We are hearing silence and mistaking it for mystery. What the ocean is truly telling us is simpler and harsher. Nothing lasts, not even stone. From sea to stone, geological anomalies. If the ocean devours, stone sometimes preserves. The shift from sea to land, from sediment to rock, is also a shift in memory. Rock layers are not generous. They compress, distort and erase, but occasionally they capture something they should not, a whisper of the unusual that lingers long after oceans have washed clean. Geologists usually look for patterns. Each layer of stone is like a page in Earth's logbook filled with minerals, fossils, and chemical signatures that reflect the world at the time of its creation. Most pages are orderly. Sand becomes sandstone, mud becomes shale, shells become limestone. But now and then a line doesn't fit. A fragment seems too deliberate, too regular, too shaped. These are the anomalies sitting in margins of the geologic record like smudges in neat handwriting. The most famous of these are the so-called out-of-place artifacts, or UU parts, objects allegedly found in strata far older than humanity itself. In the coal mines of the 19th and early 20th centuries, miners sometimes reported chains embedded in seams, bells encased in lumps of coal, even tools that seemed carved. To the men underground, the discoveries were startling signs perhaps of forgotten builders, but the accounts were rarely documented with rigor. The objects seldom preserved, and the conditions of mining chaotic. Collapses, mixing of material made contamination almost inevitable. Skeptics argued with reason that these were not relics of deep antiquity. but mistakes of interpretation or intrusions of more recent debris into older layers. Another famous case comes from South Africa, where small metallic spheres with etched grooves were discovered in Precambrian rock over 2 billion years old. To some, they looked manufactured, perfectly balanced, shaped and patterned. To geologists, they were natural concretions formed by the slow accumulation of minerals under pressure. The grooves likely the result of natural deformation. Fascinating but not evidence of technology. And yet the fascination lingers. Because each anomaly, no matter how mundane the explanation, points to the same yearning, the hope that something lies beyond the official story, that the Earth itself might carry the fingerprint of another intelligence preserved in its bones. Most anomalies fall away under scrutiny, but a few remain unresolved, not because they prove anything extraordinary, but because they resist easy classification. They remind us that the planet is more complex than we like to think, and that sometimes even science is forced to admit we don't yet know. This is the space where imagination and rigor meet, where we ask if a civilization older than ours once lived and vanished, might its traces be waiting not in the sea, but in the stone. Coal bells and forgotten stories. The 19th century was a time of wonder and upheaval. Steam engines thundered across landscapes, electricity flickered into cities, and coal, black and ancient, fueled it all. But in the mines where that coal was cut from the earth, strange stories began to surface. Miners claimed that within the dark seams, they sometimes found things that should not have been there. A chain embedded in solid coal, a small bell encased in stone, a fragment of carved metal lying where only primordial forests had once grown. For the men underground, the discoveries again seemed extraordinary. Coal, after all, was thought to be the compressed memory of ancient swamps, forests pressed flat under millions of years of rock. If an artifact lay inside it, how could it be anything but impossibly old? The tales spread quickly, retold in newspapers, pulp magazines and taverns, each retelling, adding a little more wonder, a little more certainty that these objects were glimpses of a lost civilization. But the stories rarely carried proof. Few of the artifacts were preserved. Documentation was poor, photographs non-existent, and provenance uncertain. Coal mining is chaotic, seams fracture, collapse and mix with modern debris. A loose chain could fall into a crack later, appearing embedded when the seam shifted. A misplaced tool could become encased in dust and slurry hardened until it seemed part of the deposit itself. Skeptics had ready explanations, and rightly so. Without rigorous evidence, the artifacts could not be trusted. Still, the allure persisted. A bell in coal is more than an object, it is a story, one that invites imagination. Perhaps it was the remnant of a forgotten age. Perhaps it proved that our history was deeper, stranger, more layered than the textbooks allowed. To the miners who spent their lives in the dark, the idea that their work might uncover secrets millions of years old must have been irresistible. Historians and scientists today view these accounts with caution, placing them alongside tales of petrified giants or fossilized tools in ancient rock. Most are explained as errors, hoaxes, or misinterpretations, but even so they reveal something profound about us, our hunger for continuity. We want to believe that we are not the first, that others walked before us, leaving faint hidden messages in the Earth's oldest layers. The bell in the coal, the chain in the seam, whether true or not, are less about evidence than about desire. They show how easily human imagination rushes to fill the silence of deep time with echoes of itself, and that in its own way is a truth as enduring as any fossil. Anomalies and the burden of proof. Science thrives on anomalies, but it does not rush to embrace them. Instead, it tests questions, doubts. A single strange object, a curious chemical spike, a story of something out of place, none of these alone are enough. For an extraordinary claim, the burden of proof is extraordinary as well. The history of science shows this pattern again and again. When Alfred Wegener proposed continental drift in 1912, his peers scoffed. Continents, they argued, were fixed. His evidence, the jigsaw fit of coastlines, the matching fossils across oceans, was compelling, but without a mechanism, it was dismissed as fantasy. Decades later, when plate tectonics supplied the missing explanation, Wegener's anomaly became the cornerstone of geology. Similarly, when Luis and Walter Alvarez presented their theory in the 1980s that a meteor impact ended the age of dinosaurs, the idea seemed outlandish. But the thin global layer of iridium, the anomaly demanded explanation. Over time, with crater evidence at Chicxulub, the theory moved from fringe to consensus. What began as a puzzle became a paradigm. This is how science approaches anomalies, with suspicion, but also with patience. Most are explained away. A supposed artifact in stone turns out to be natural concretions. A city wall beneath the sea is revealed as fractured sandstone. The extraordinary explanation is rejected in favor of the ordinary one, and most of the time that conservatism is correct. But the lesson is clear: anomalies must not be ignored. Today's unusual data point may, with the right question, become tomorrow's revelation. The risk is not only in false belief, but in blind dismissal. If a genuine trace of intelligence from deep time exists in a mineral deposit and isotope ratio, a chemical residue, it may be catalogued right now as unexplained and left to gather dust in a database. And this is the tension at the heart of the search for lost civilizations. Science demands rigor, and rightly so, but rigor sometimes hardens into rigidity. And when that happens, the line between healthy skepticism and blindness grows thin. The burden of proof will always be high, it should be. But the cost of ignoring anomalies, of refusing to ask whether a pattern means more than geology, is the possibility of missing history itself. Because history, as the past has shown us, is often written not by what we already understand, but by the anomalies that refuse to go away. Chemical signature. Signatures occur in stone. Stone may seem sane, but in its chemistry it remembers. Geologists know that within certain layers the balance of elements shifts abruptly, almost like punctuation in Earth's story. These moments are called isotope excursions, sudden global changes in the ratios of carbon, oxygen, or other elements that point to dramatic transformations in the planet's systems. Some of these shifts are well explained. A surge in volcanic activity can pour carbon dioxide into the air and oceans, leaving behind a telltale spike in carbon isotopes. A methane release from thawing permafrost can produce similar effects, rapid warming, recorded in thin slices of sediment. An asteroid impact scatters not only debris, but rare isotopes like the iridium layer that testifies to the end of the dinosaurs. In each case, the cause is natural, catastrophic, and legible to science. But not all excursions are simple. The Paleocene-Eocene thermal maximum PE-TIM, around 56 million years ago, remains one of the most dramatic. In less than 20,000 years, a blink in geological time, global temperatures soared, oceans, acidified ecosystems collapsed. The chemical record shows a massive sudden spike in carbon isotopes. Yet debate continues: was it volcanic activity, destabilized methane hydrates, or something else entirely? The data speaks clearly, but its interpretation remains unsettled. Here lies the unsettling parallel. If an industrial civilization were to rise, burn fuels, release gases, and alter planetary chemistry, its legacy would look much the same. A sharp, unnatural carbon spike compressed into rock, global and synchronous. To a future geologist with no context, the signal might appear identical to the PETM rapid warming acidification collapse. Nature provides many ways to mimic what industry produces, and therein lies the problem. How do you tell the difference? Our own fingerprints are already being written into stone. Rising carbon dioxide, increasing methane-nitrogen cycle disruptions from fertilizer use. All of these will leave measurable marks in future strata. Scientists already call this the Anthropocene, an epoch defined less by what we build and more by how we alter air, soil and water. Plastics, isotopes, technofossils, yes, but the most global enduring signal is chemical. If we disappeared tomorrow, our buildings would crumble, our machine corrode, our archives vanish. But in the rocks, the chemistry would remain. A spike unlike any other in tens of millions of years. To future eyes, it might look catastrophic, even unnatural. But would they know it was us? Or would they file it under anomalous warming as we ourselves do for the PETM? The haunting possibility is that such signals already exist in the record, subtle, misinterpreted, explained away as volcanism or methane. Perhaps somewhere in stone there is already a sharp synchronous change, global in reach, caused not by nature but by something like us. And perhaps we have seen it, measured it, and never recognized it for what it was. Myths as memory. When the artifacts are gone and the stones are silent, stories remain. Myths do not preserve dates or measurements, but they carry impressions, shadows of events retold until their sharp edges blur. For millennia, humans have passed knowledge, not by inscription but by voice, and sometimes those voices remember far longer than we think. Across the world, flood myths appear with startling regularity. In Mesopotamia, the Sumerians told of Ziu-Sudra, warned of a deluge by the gods. In Babylon, it was Utnapishtim. In the Hebrew tradition, Noah. In Greece, Deucalion and Pyrrha. In India, Manu guided by a fish. In Norse sagas, a flood followed the death of Ymir. In the Americas, Hopi, Aztec and Inca traditions speak of waters rising to cleanse the earth. The stories vary, but the core remains: as water overwhelms the old world, is swept away, a remnant survives. For centuries, these tales were dismissed as simple metaphors, symbolic warnings about hubris or divine punishment. Yet geology tells us that around 12,000 years ago, as the last ice age ended, seas rose more than 100 meters. Entire coastlines drowned, valleys became bays, plains became seas. To the people who lived there, it must have seemed as if the world itself was ending. Their descendants may well have carried that memory and story long after the landscapes themselves were lost. Anthropology gives us modern confirmation of how durable oral tradition can be. Australian Aboriginal peoples have stories describing coastlines that were drowned over 7,000 years ago, stories later confirmed by geological evidence of rising seas. In North America, indigenous tales recall volcanic eruptions and earthquakes that align with known geological events. Oral history can endure not decades but millennia, encoding real experiences in symbolic form. This opens a possibility both thrilling and unsettling. What if some myths do not merely describe ordinary floods or disasters, but echo events so large, so transformative that they reshaped entire civilizations, the destruction of cities, the loss of knowledge, the erasure of worlds? It does not prove lost civilizations. Myth is not measurement, but it reminds us that human memory, even before writing, could preserve fragments of reality across vast spans of time. When we read of Atlantis in Plato of Lemuria, in Victorian speculation of Kumari Kandam in Tamil tradition, we are not hearing literal accounts, but we may be hearing echoes, faint, distorted, but not entirely imagined. The line between memory and myth is thin, and sometimes that line is all that stands between silence and the possibility that something happened long before history admits. Atlantis and the allure of lost lands. Few names stir the imagination like Atlantis. First described by Plato in the 4th century BCE, it was said to be a vast island kingdom beyond the Pillars of Hercules, rich in power and knowledge, before it fell in a single night of catastrophe. Scholars generally read Plato's tale as allegory and exploration of hubris and justice, not geography. Yet the idea of Atlantis has proven stronger than allegory. It has become the archetype of every lost civilization, every whisper of a drowned world. But Atlantis is not alone. In Tamil tradition there is Kumari Kandam, a great land said to have stretched far into the Indian Ocean before the waters rose and swallowed it. In 19th century Europe, mystics spoke of Lemuria, an imagined continent bridging Africa and Asia, invented to explain the distribution of species before plate tectonics offered a better answer. Celtic lore remembers Lyonesse, a kingdom west of Cornwall drowned by the sea. Irish tradition speaks of High Brazil, an island that appears only rarely shrouded in mist before vanishing again beneath the waves. The details differ, but the theme is consistent: lands that were and are no more. Some are allegory, others national myth, still others fabrications of colonial imagination. But what unites them is the deep human sense that the sea is not only boundary, but thief, that it has taken something precious and refuses to return it. Why do these stories persist? Partly because they speak to universal anxieties, the fragility of home, the terror of sudden loss, the suspicion that what we know is only a fragment of what once was. Partly too because they carry a romantic lure. A vanished world is the perfect canvas for imagination, advanced yet forgotten, powerful yet doomed, close enough to believe, distant enough never to disprove. And beneath the allegory there may be kernels of memory. We know sea levels have risen and fallen dramatically over human history. We know entire landscapes, Doggerland in the North Sea, the Sunda Shelf in Southeast Asia, were once dry land, later drowned. To ancient peoples, those changes must have seemed like the sinking of worlds. The myths could be distorted memories of real places swallowed by water, retold across generations until they became legend. Atlantis, Lemuria, Kumari Kandam, none may be real in the way storytellers imagined them, but their persistence shows us something important. Even without ruins to point to, humanity senses that the earth is full of absences, that what is visible is only part of the story. In every culture, the sea is more than water. It is a veil hiding worlds that might have been, and tempting us to imagine the civilizations that could still lie beneath. The archaeology of absence. Archaeology is often imagined as discovery ruins, rising from the sand skeletons, brushed free of dust artifacts lifted into the light. But much of archaeology is not what is found, it is what is not there. The gaps, the silences, the absences that shape what we think we know. History, after all, is uneven. Some cultures left stone monuments that endure for millennia. Others built with wood, clay, or fibre vanishing almost without trace. Some regions were favourable to preservation: dry deserts, frozen tundra, sealed caves. Others, like humid forests and river deltas, swallowed almost everything. Entire peoples may have lived and died in those landscapes, leaving behind little more than shadows. Consider the Indus Valley civilization. For centuries it thrived, with planned cities, plumbing and trade networks stretching across Asia. Yet its script remains undeciphered, and the reasons for its decline are still debated. We know it existed, but vast parts of its story are silent. Or the Minoans of Crete, builders of labyrinthine palaces, seafarers of the Bronze Age. They left behind art tools and ruins, yet their language remains only partly understood. Their disappearance coincides with earthquakes and volcanic eruptions, but no definitive cause has been found. The silence remains louder than the evidence. And then there are the civilizations we know only from the words of others. Tribes mentioned once in an ancient text never seen again. Cities described by travelers but never rediscovered. In those cases, the absence may mean loss, or it may mean we have not yet looked in the right place. Absence itself tells a story. It warns us that our picture of history is incomplete, skewed toward what happened to survive rather than what happened most often. It reminds us that the everyday lives of billions, their songs, their laughter, their fears, are almost entirely invisible to us. What remains are fragments, hints, and ruins. This is why a speculation about lost cities, about vanished worlds, will always have a place. Not because the speculation is proof, but because the silences demand imagination to fill them. And in that act we remember that history is not a finished book, but a manuscript with missing pages. Every absence is an invitation to look again, to dig deeper, to listen more carefully. Because sometimes the most powerful story is not the one we uncover, it is the one we can barely hear at all. When myth meets memory. For centuries, myths of lost lands and great catastrophes were dismissed as pure invention parables, fables, cautionary tales. Yet increasingly science has shown that memory lingers in ways we once underestimated. Beneath the embroidery of gods and giants, stories sometimes preserve kernels of truth. Take the great floods. Nearly every culture carries a story of waters that rose without mercy. In Mesopotamia, the Epic of Gilgamesh describes a deluge that wiped out almost all humanity. In the Hebrew Bible, Noah's Ark rides out 40 days and nights of flood. In Hindu tradition, Manu is warned by a fish to build a boat before the waters rise. Aboriginal Australian stories recall seas advancing inland, drowning once inhabited plains. At first glance, these tales seem symbolic. But geology tells us that around 10,000 years ago, as the Ice Age ended, seas did rise, sometimes violently swallowing coastlines and reshaping worlds. Could the stories be ancestral memory passed down over millennia? Volcanoes too leave their mark. Legends of fire and ash often correspond to real eruptions. The Minoans' decline may be tied to the eruption of Thera Santorini, remembered in tales of darkness and tidal waves. In the Pacific, oral traditions describe mountains that blew apart, fire that rained from the sky, ash that turned day into night. Modern science has traced those accounts to eruptions we can still measure in the geological record. Earthquakes, comets, famines, each leaves scars, not just in the earth, but in memory. Over time, the details shift and gods replace natural forces, but the core survives. What was once trauma becomes myth. What was once event becomes allegory. Yet embedded in the allegory is a faint signal of history. This blending of myth and memory complicates our view of lost civilizations. When we hear of cities drowned, mountains shattered, or land swallowed whole, it is tempting to dismiss them as invention. But the persistence of such stories across time and geography suggests they are more than idle fantasy. They are cultural memory, imperfect, refracted, embroidered, but still memory. And this is why lost worlds matter, even when they are not real. They remind us that human beings have always sought to explain catastrophe, to turn terror into story. In doing so, they left us echoes of events so ancient that no other record survives. The myths may not give us coordinates, but they give us continuity, an unbroken thread from the storytellers of the past to us listening still. Atlantis and the allure of the ideal. Among all tales of lost worlds, none has cast a longer shadow than Atlantis. Plato wrote of it in the 4th century BCE, framing it not as fantasy, but as a cautionary parable. A mighty island empire, rich in resources and knowledge, grew arrogant. It sought conquest, defied the gods, and in a single day and night of misfortune vanished beneath the sea. For Plato, Atlantis was moral allegory, a warning about hubris, greed, and the fate of societies that place power above wisdom. Yet over the centuries, Atlantis has been read less as metaphor and more as map. Explorers, philosophers, and mystics each claimed they could locate the sunken city. Some placed it in the Mediterranean near Santorini. Others looked to the Atlantic Ocean, the Caribbean, even Antarctica. Each new theory said more about the seekers than the story itself. The power of Atlantis lies not in evidence, but in what it represents. To some, it is a dream of a perfect society, a golden age lost to time. To others, it is proof that greatness can collapse in an instant. To still others, it is a secret waiting to be rediscovered, a reminder that the world hides mysteries just beyond our reach. The Renaissance revived Atlantis as scholars rediscovered Plato. Enlightenment thinkers reimagined it as a model of reason and order. In the 19th and 20th centuries, occultists and adventurers claimed it as the cradle of hidden wisdom, a place of crystal energy and forgotten technologies. Even today, Atlantis thrives in novels, films, and popular imagination, not because we have found it, but because it reflects what we seek. Atlantis endures because it is adaptable. For some, it is utopia. For others, it is tragedy. For many, it is possibility. A blank canvas onto which each generation projects its anxieties and its ideals. Whether or not Atlantis ever existed is almost beside the point. What matters is the role it plays in reminding us of fragility, ambition, and the dream of something more. In that way, Plato's allegory has succeeded far beyond its original intent. Atlantis is not just a lost world, it is a mirror one we still hold up to ourselves. From the frozen mammoths of Siberia to the drowned ruins whispered of beneath the waves, lost worlds are less about the places themselves than about us. Each tale, Atlantis, Mu, Lemuria, Hyperborea, El Dorado, carries the same weight, a sense that what we see today is only the surface of history, and that beneath it lies something vast, hidden, unfinished. Why do these stories endure? Because they speak to three things deeply human. First, longing. We imagine golden ages behind us, times when people lived in harmony or possessed wisdom now forgotten. This longing makes the present feel connected to something greater. Second, fear. We know civilizations can fall, Rome teaches it, the Maya. Remind us even modern empires tremble. Myths of floods, fire, and sinking lands echo that fear that what we build can vanish in a heartbeat. And third hope, if worlds have been lost, perhaps they can be found again. Perhaps their wisdom, their treasures, their mistakes are not gone but waiting. Science gives us tools to separate myth from geology, archaeology from legend. Yet even as we measure, dig, and carbon date, the allure of the lost remains, because the power of these stories is not only in whether they happened, but in what they mean. They remind us that memory is fragile, history incomplete, and imagination eternal. To dream of Atlantis is to dream of justice and hubris. To whisper of Hyperborea is to long for purity in a world gone dark. To seek El Dorado is to chase not just gold, but promise. The names change, the maps shift, but the human impulse does not. We tell these stories because we need them. And so when we look at the horizon, at seas hiding coasts, we no longer walk at forests covering ruins. We no longer build. We are not only searching for what is gone, we are listening for echoes, for voices that remind us that civilizations like people live, falter, and leave behind only fragments. The wonder is not that worlds are lost, but that their stories survive. In the end, the truest lost world is not a continent under the sea or a city in the jungle. It is the vast expanse of human memory itself, half preserved, half forgotten, waiting always to be rediscovered. Thanks for being here. Hit that subscribe button and join us for the next chapters full of history and discovery.